Hello. Hi, everyone. Welcome. It's great to see you all. Thanks for joining. Welcome to day 3 of the UK Greenhouse Gas Removal event. So great to see some familiar faces, some new faces. Let me introduce myself. My name is Emily Swaddle. I co-host a podcast called The Carbon Removal Show. So if you recognize my voice, that's where you know it from. I'm also the co-chair of the Future Leaders Network, which was an initiative by CORE and brings together people who are in the early stages of their career in GGR across the UK. It's very exciting. So I'm going to be your host today, and I'm going to be sort of popping back in at various points to make sure we're on track and to get everyone comfortable here on this very historic stage. So for those of you who weren't here yesterday or on Monday, welcome to the Royal Institution. It is truly a historic stage. This theatre has been in use since 1802. I looked it up before I came. And the Christmas lectures have been happening here since 1825, which is pretty impressive. I feel very honoured to be standing on this stage that has held so many big names. People who have sat where you're sitting right now in the audience include Charles Darwin. Ever heard of him? Also, the poet, Lord Tennyson, was sat where you're sitting. The lecture that he was watching actually demonstrated the very first sound recording, and it was one of his poems that was recorded and played back to him. In more recent times, people like David Attenborough have stood right here, Jane Goodall. Big, big names, and now we're going to get some amazing pictures from the future of GGR. It's very exciting. I am excited to have everyone here. I do need to go through a few housekeeping things, so please just bear with as we take a look. So, first of all, we are here to connect in person, but we do have Wi-Fi in the building. Let me just get that up. Here we go. You can connect online if you wish. The toilets are downstairs at reception. You might pass them on your way in. Please bring no food or drink into the theatre here. You are allowed bottled water, I believe, but no food or drink other than that. The catering will be on this floor through there in the library. I think you've already been mingling there. We'll have another break later on where you can continue and get some coffee. All the fire exits are marked with the green lights. And we'll gather by Churchill on a bench outside on the street to the front. Please keep your badges on you so people can see who you are. The red lanyards are for staff. So if you have any questions, find somebody who's got a red lanyard. And enjoy yourselves. I think that's the most important thing to remember today. So before we dive into the pictures and any more talks and everything, I want to introduce David Contreras, our organizer for today, who's going to tell us why we're here. Thank you, David.
Well, before I go into the agenda, you know, when we came up with the idea of a GGR day in terms of innovation and showcasing just the talent in GGR that we can offer to the world, I was looking for a special MC, you know. Instead of going to another people, you know, I thought, well, we can keep it local talent. And that's why I decided to contact Emily. Emily, I think that is wonderful. You're going to have an amazing time with Emily, I think. But why we're here, obviously we're here to celebrate the innovators in this country that are coming up with amazing, very cool ways to lock up carbon, monitor GGR, or really helping us in the path to net zero and beyond. So what we decided is, well, let's make it into a competition, right? We all love a bit of competition. I work for CORE and for Undaunted, so that's sort of part of our DNA. And we decided, well, let's see the pitches that we can get. We actually got really amazing applications. and the top 9 are going to be presenting with us, okay? So this is sort of the layout. We have also amazing keynote speakers. Gabriel's going to come after me, after you. But, and we have curated the session in 2 buckets, if you like. Some that are not GGR in particular, but are related to either hydrogen monitoring or better ways to absorb carbon in CCS, for example. We have nitrous oxide destruction as well. So really interesting mix in the first half. Then we have Alisa, my boss, who's going to be, delivering the keynote speaker at the second part. And then we have a batch of more, if you like, traditional, because they're not traditional at all, GGR methods are going to be showcased. But the reason why we're here is because from all these 9 amazing startups, we're going to have the top 5, and we're going to have 4 judges evaluating them according to criteria in terms of scalability, climate or GGR impact, in terms of the innovation, their team, obviously the program suitability, or what we're building as a GGR sector-specific accelerator with the help of Undaunted as well. So we have an amazing program that we're putting together that's going to kickstart in November. And it's going to be tailored to the specific of these top 5 companies that you're going to see today. The other ones are going to be also amazing, I'm sure, and it's going to be a top call for you judges, so good luck with that. In any case, enjoy the day. I hope that you have a fantastic time. I leave you with Emily.
Thank you, David. Okay, I want to kind of get to know you all in the audience a little bit before we get to know our startups here. So can I see a show of hands? How many of you have been working in CDR or CDR-related space for the last year, for 1 year? Lots of hands, excellent. What about 3 years? Still lots of people with their hands up. 5 years? Oh, we're thinning out. 7 years? 9 years? Doesn't exist. CDR's too young. Okay, amazing. Amazing. And how many of you have worked for a startup or currently work for a startup? Okay, a lot of people, amazing. And how many of you have stood maybe in a theater a bit like this and presented to a whole bunch of people? Yeah, quite a lot. So a lot of us know how it feels to be in this position, and it can be very daunting. It can be nerve-wracking. You can find yourself a little bit maybe frozen or maybe unsure of yourself suddenly. So our job collectively is to make sure that the startups, when they're here in this position, do not feel that. Our job is to make sure that the startups feel supported, like we've got their back, we're rooting for them, we're their cheerleaders. Do you think we can do that? Okay, great. I do believe you, but I would like to see it in practice. So I'm going to go off, and then I'm going to introduce myself, and then I'm going to come on, and I want to hear how supportive you are of me. Okay? Okay, so I'll be over here. Emily Swaddle. Thank you. Thank you. Thank you. That was perfect. I was going to get you guys to do it again, but honestly, you nailed it. Amazing. That's exactly what's going to happen when the startups come on. They will do their pitch, and then we're just going to do the exact same again and support them when they go off as well. So thank you so much for that. Beautiful to hear all your support for these startups. I'm really excited to hear their pitches. But before we get into that, we are very lucky to have with us today Dr. Gabriel Walker. Gabriel is the co-founder and chief scientist at Curate. She's a scientist, author, and entrepreneur with a deep understanding of climate change and energy transition issues in business, policy, and in science. A former professor at Princeton University with a PhD from Cambridge University, she's been an advisor on energy, climate, and policy at C-level to Fortune 100 companies and co-authored Hot Topic, a best-selling book on climate change. Please join me in welcoming Gabriel Walker.
Well, that's not fair. You got whoops. I didn't get whoops. Where are the whoops? Come on, give me some whoops. Whoops! Woo! Thank you, thank you. So I'm beyond thrilled to be here for several reasons. One of them is that in 2003, I wrote my first book, and it was published in 2003, and I launched it by giving a lecture in this very place. It was when they had the old desk, which had all the burn marks on it from the sort of 19th century experiments. And so it's kind of thrilling to be here 22 years later and doing this. I have spoken here before, and also a bit alarming how far we haven't come. Right, so one thing I'm just going to romp through. I was asked to talk a bit about the context of carbon removals. All of you, most of you will have seen most of this before, heard most of this before, said most of this before, but I hope everybody gets something at least a little bit new or a different way of framing something. And some of you, hopefully, will get a lot out of what I'm going to say now, but it's just a context setting for why we even care about removals, what they are, and why it's important what's going to happen this afternoon. A quick disclaimer. Sadly, I have to run straight after this, racing out there trying to find more buyers and build more market for removals. I will be live streaming though, because I really, really want to see what the talent is going to be for the next steps in this. And I'm very, very excited about the role that the UK can play in removals and already is. So apologies for running off, but please believe me, it's not any lack of interest, it's actually the opposite. Right, with that, here we go. So we are the UK Innovation in Carbon Removals, the UK GGR Event. First of all, just a word or two about me. I said that I started off, I did my first book in 2003, I was speaking here. I have actually been working on climate change in different aspects for more than 30 years. I was climate change editor at Nature back in the 1990s, that's how old I am. And I feel like I always feel like I need to apologize to everybody present that I haven't fixed it yet after all that time, but I do not give up easily, I'm still going. And for most of that time, I was working on carbon reductions across every sector and across, you know, with NGOs, with businesses, with policymakers, with think tanks. I switched to carbon removals about 7 years ago, so I still have my hand up at 7 years, for two reasons. I was alarmed, terrified really, at the size of the gap and the realization that this wasn't something that was being dealt with. It's not as someone should do something, lots of people are doing it. This is the biggest gap I'd seen in the entire climate space with the least attention and energy going into it. But also excited by that, because this is going to be $1 trillion or more industry. This is something that's going to be hugely important to build, and we are right at the beginning of it. And in all that time that I've been working on every aspect of climate, I have never touched anything this exciting. So it's alarm and excitement in more or less equal measure most days. So what I'm going to talk to you about now relates to the two organizations that I co-founded. So I also co-founded Rethinking Removals. That came first. It's a non-profit that's dedicated to understanding the market very deeply, building narratives that are more helpful in the removal space, and inserting those directly into policy and in voluntary rules, and also hopefully in compliance as well, and working with everybody else who does that. So that's Rethinking Removals. Sister organisation to my main effort, which is Curate. This is a for-profit startup. We help organisations, mainly companies, corporates, to plan their carbon removal strategy, to purchase carbon removals, to identify them, to work out, to do the due diligence, to put together the portfolios, to manage them, and also to forward finance them. And I'm going to say a little bit more about the need for forward financing, but also what's actually needed in the market when I get to the end of this. So that's just who I am, why I'm here, how I've learned all the things that I'm talking to you about. So I am just going to say something about what carbon removals are not. And I say not offsets, and the scientists in the room will say an offset is not a thing, it's a verb. Offsetting is something you do, it's not something you have. But there has been this massive confusion in the field of offsets, aka avoidance credits, being conflated with carbon removals, and I think that's been a big challenge for us. So let me just say a word about that. When I started off in this game, it always felt like climate change was all about tree hugging. Anyone else? And then this happened. really about 9 years ago maybe, it started to be clear to the financial services sector that this is something that actually mattered to business. The climate risks are uncertain but predictable. They will affect every consumer and every corporate in all sectors and all geographies. That's Sarah Breeden, who is the Deputy Governor of the Bank of England. So that led to this. The last time I looked, I checked the global net zero tracker. In 2019, almost nobody had a net zero target. But last week, 92% of global GDP generators, aka companies, either have set their own net zero target or they're operating in a territory that set theirs. 92%. This has gone massive. And that led to, okay, what do we do about this? We know how to do the reductions. What about the net? So the net in net zero had this stampede towards the global carbon markets. I'm not going to labour this point. It's just we all know that that hasn't ended well. So we had a problem. The carbon market started crashing. There were big challenges about integrity. The rules to try to avoid that, to stop people gaming it, became extremely complex. This is what I think went wrong. So this is a picture of me walking the Camino de Santiago in Spain. Has anyone done that? Fewer hands than working on removals. I recommend it. It's great. Especially if you're trying to do something extremely intractable. It helps to go for a long walk. And this was 500 miles. So it was a really long walk. I did it in 2020. I put it in there because it's an ancient pilgrimage route. So in ancient times, if you walk the Camino de Santiago, you walked it, you got to the cathedral, you had mass, you had your sins washed away. Fantastic. When I was walking it, I thought maybe I should do some extra sins on the way just to get extra bang for my buck. I already have plenty, so it's fine. The reason I've put it up here is because in medieval times, if you were rich enough, you didn't have to walk it yourself. You could pay someone else to walk it. They did all the work, and then you got your sins forgiven, and you got a piece of paper to prove it. Is this sounding familiar at all? You're way ahead of me. So here's the point, that for any kind of credit, that doesn't work, that doesn't make sense. And I do think that there are important things that these different credit projects, avoidance and removals, need to do. So there's reduction credits. Those are credits that are actually helping to transform fossil infrastructure in places that can't otherwise afford to pay for it. That's important. There's protection ones that are stopping natural carbon from coming out of natural sinks, like rainforests and stuff. Very important. And there's carbon removals. And what I want to say here is that different credits do different things. Reduction and protection are contributions, essential contributions to the world's climate goals. Removals are not traditional offsets. They are the net in every net zero target. They are the only way that you get net zero. What goes up must now come down. Are we clear on that? Right. So, removals. Now, different methods. Whenever I talk about removals, people always say, which one's the best? Or do you mean trees? Or sometimes do you mean machines? So I'm just going to labour this point for everybody. It's a portfolio. It's a spectrum. We need all of them. And that's one thing I really want to stress here. I'm going to talk through some of these methods. We're going to have some very innovative methods later today with the pitches that come along. But broadly speaking, the slightly mainstreamy removals come across this kind of spectrum. So there's durable forests. Doing forests right, not just planting plantations of eucalyptus, but actually considering how to make the forests sustainable, how to make them resilient to fires and to pests, to make sure that they actually have some kind of durability. In the corner, you'll see that there's this, each of the methods I'm going to show you has that range. This is what my company Curate has assessed the methods for, to say, what are they really good at? Co-benefits, storage integrity, brand impact, durability, technology readiness, quantification certainty, and environmental integrity. I think it's brilliantly ironic that trees have the highest technological readiness level of anything that you will see, because we know how to do them, but they're really not so good on storage integrity. Each one that I show you is going to have different things that they're good at and bad at, and that's why we need to think across the whole range of removals in a portfolio way. So then there's soil carbon. Soil carbon a bit more challenging, particularly in the measurements and the storage integrity. There's biochar, this brilliant stuff that you can get offcuts from timber or from the shells from nuts or the husks from rice. And you can burn it in the absence of oxygen, locking up the carbon inside this charcoal-like material. It's fantastic for improving the quality of the soils. It was invented by native people in the Amazon rainforest, not to solve climate change, but to improve the soils. So this is a way to actually get yields, increase resilience of crops, and also lock up carbon. Hence, it's a cracker. It's also quite high on the technology readiness level. It is most of the removals that are currently being sold. Then you've got enhanced rock weathering, more of a newbie on the block, but still something that involves field. So this is taking a natural process that soaks up CO2, mainly basalt rocks that do it over 10,000 years or so, grinding up the rocks that you increase the surface area, you speed up the reaction, and you can do this in a matter of decades. Spreading it onto fields, generating minerals that can then improve the yield from the crops. So this is another one that requires land to be able to use it, but also has this side benefit that's not kind of just, we might be able to improve biodiversity here, but we can also improve crop yields. We can give farmers something that improves their quality of life. We can give businesses something that means that they want to get engaged in it. Alkalinity enhancement, this covers rivers, it also covers the ocean. Liming where it's got more acidic and actually taking up CO2 in the form of bicarbonate ions, which are very durable. This is a particular river one. It's quite clever because if you try to do this in the oceans, you put in your lime, then where does it go? How do you monitor it? In a river, you can actually just go downstream and see what happened. And so there's lots of ways that you can use this. You can also use this in wastewater treatment. Biogenic CO2 capture. So this is one of my favorites because I went to visit it. It's a whiskey distillery. So this whiskey distillery in Scotland had all this CO2 just pouring out of it and didn't have anything to do with it. And so along came the carbon removers and said, we'll help you with that. And they've made a system that is very scalable because it's very modular. Put this on the back of it. It can work for biogas plants. It can work for other distilleries. Take the CO2 and transport it off in trucks. And then, of course, there's direct air capture. This is lower on the co-benefits and on the brand impact, fantastic storage integrity, quantification. You capture the CO2 in capture devices. You have it in a blimp. You can weigh it. And this is a site that's about to be commissioned in Texas. I kind of like this one. It's the poetry of it. It's right in the middle of oil country, but everyone else is pulling the oil out, and this is putting it back. So you go past all the nodding donkeys of the past to get to the future. And this is going to do 500,000 tons a year. So it will be way the biggest direct air capture plant coming out now. So I just wanted to do that, just to remind everyone, and there's more. When I started on carbon removal 7 years ago, direct air capture was a glint in a few people's eye, and there was almost nothing else. So one thing I really want to stress about this, before you hear the people who are going to come and give the pitches, is this isn't just inventing one technology out of scratch. This is inventing an entire industry. And that means that entrepreneurs and startups have an outsized role in doing this. There are no incumbents. There are no incumbents. And that's really exciting if you're of an entrepreneurial bent, so just bear that in mind. Right, just a little bit on the market. So removal projects are growing. They are issuing more credits year on year from a very tiny base. So this is small, this is early. We need to accelerate very dramatically. And so I'm always looking out for not just what will make this happen, but what will accelerate it. How do we drive this much, much faster than we currently are? Prices are also rising. They will eventually fall, but this is one of the things that actually helps when you're trying to get buyers to engage with this. Because if you say to them, buy carbon removals, they'll say, well, wait, the prices are going to come down. And you have to have an argument if you're one of these chief sustainability officers for your chief financial officer. And question one that the chief financial officer asks is anyone telling us to do it? Question two is, what's anyone else doing? And question three is, what do I get? What value do I get from doing it now? So this is an answer to the value you get for doing it now. And this is an answer for, is there anyone telling us to do it? What governments are doing and why? So it's super interesting. We've got these, the voluntary standards I put up there. So you've got the Oxford Offsetting Principles. You've got ICVCM, the Integrity Council for the Voluntary Carbon Market, which has brought out its core carbon principles and has just ratified another big slew of removals methodologies. So that's bringing the integrity back into the market. You've got the Science Based Targets Initiative, and you've got the ISO Net Zero Aligned Organization Standard. SBTI and particularly ISO's coming out next year. It will say that you need interim targets for carbon removals, and you need to start engaging now if you have a net zero plan. So that's really important because it's starting to give businesses, is anyone telling us to do it? But it's not compliance. And really what the CFOs want to hear is governments are telling us we have to. And currently, governments are not. And that's a big challenge. But we are starting to get some signals from the future. Oh, and I'd like to say we're in the kind of pre-compliance phase at the moment. So like the Japanese ETS, the UK, which is really playing a blind door on this and has already published on incorporating removals into their ETS, the contract for differences that they put into their greenhouse gas business model, greenhouse gas removal business model. The EU is already engaging, looking at the CRCF, the carbon removal certification framework. Government purchases are already starting, small ones, but from the US, Canada, Germany. They're small signals, but they're starting to come, and we need to blow them into flame. These little signals blowing oxygen onto this. What about the other question? What's anyone else doing? Well, when we started in this game, it was basically Microsoft. And it's still basically Microsoft. Microsoft is buying more or less like 85% of the total purchases that have been made. But the good news is that a lot of other companies are stampeding along. So this is just a selection of companies that are now buying carbon removals at a meaningful scale. So there's obviously lots of tech in there, but you can see that there's also fast-moving consumer goods, there's retail, there's airlines, there's financial institutions, there's professional services. This is starting to get into the mainstream, and all of my work with Rethinking Removals, and especially with Curate, is to accelerate that process, to find new ways to engage new buyers, to show that there's a real market in this. Because the way that we are going to grow carbon removals is to get money in the hands of the entrepreneurs who are building it. We have to get money in the hands of the people with the shovels. And the way we do that is we prove a future market so the banks, which are dying to lend, can actually send the money along. So this is operation, prove this is real, prove a future market. And that's why this focus on getting companies to engage at any level to show that this is real. And I just wanted to give you that picture of how these things tie together, the voluntary rules, the coming compliance, the action of the companies. It's all in the service of getting money in the hands of the people, the entrepreneurs who will actually build this thing. This is why the companies are doing it. So some of them, they want to talk about more regenerative ecosystems. In some cases, it's decarbonizing via the supply chain. That's something that's really starting to come now. Others want to lock in a preferred credit supply. They're aware that the prices are going up, the availability is going down. Some of them want to stay ahead of the rule changes. And some of them want to integrate removals into new business lines, actually make money out of it. And these are all the ways that we're engaging with buyers now. Just wanted to give you a few live examples of that. So this is just work that we've done at Curate. There's lots of other live examples out there, but I like these three because they exemplify different approaches. So British Airways, at a stroke, became the biggest purchaser of carbon removals of any UK company and of any airline. And they did it with an innovative portfolio. They wanted to invest in innovation across the entire range of removals. They say, we are going to need these. If we're buying them, we want to be making sure we're doing it for the companies that can really scale and get us access to credits. So that was their point, is innovating to support an industry that's going to be critical for aviation and for the right to continue to do business. Coca-Cola, slightly different one. They're on their net zero path. Most of their focus is on reductions. They know they're going to need removals, so they're starting to engage with it. So they're doing it with events, they're doing it with travel, so they can start to build that internal muscle. And finally, I promised you that I was going to say something a little bit more about forward financing. So we did this work with Standard Chartered Bank to forward finance an offtake, make sure that offtakes that are coming along from companies are bankable. And this is a way that the company doesn't need to pay the money up front, which the CFO likes, but the money goes into the hands of the people with the shovels. And that is more essential than anything else in this space, because we are not talking about companies with big balance sheets. We are not talking about incumbents. We're not talking about organizations that have big R&D budgets. This entire field, we are inventing this entire field out of nothing. And therefore, we have to have ways that the banks can engage and manage risk that they don't really understand. So that's me. I say the science is clear. We need carbon removals. You all know that. I hope that everybody got something out of that. But the last thing that I want to say here, I said at the beginning, this is really exciting. It's also really alarming. It's also really exciting. I do go through that cycle of quite intense emotions about carbon removals every single day. But I will also say that the way that we will solve this is by the energy and the power of all of you in this room, and then everyone else is going to come behind that. So I just want to finish with everyone. Can you all stand up? Can we have some lights, please? Lights, please. Thank you. Look around. And please give yourself a massive whoop, whoop round of applause. You are the ones who are going to fix this. Do not let me down. And thank you.
Well done, everyone. Thank you to Gabriel. I very much relate with the emotional roller coaster of working in CDR that she described. Don't know if you guys also feel that. Okay, so we're all warmed up. We're ready to go. We know the stakes as clearly outlined here by Gabriel, the context, the stakes. So now we're going to dive into some pitches. That's what we're all here for. I'm very excited about it. The way this is going to work, each startup is going to come and stand right here. They're going to get 5 minutes to tell you their story. We're going to be strict with their 5 minutes. They're only going to get 5 minutes. Then they're going to get 5 minutes of questions from our lovely judges, who I will introduce in just one moment. In the first half, we have 5 startups pitching. In the second half, we have 4 startups pitching. And across the day, we have 2 startups who are going to be actually remotely joining us on the screen, so they're not going to be here in person. At the end of the day, the judges will decide the top 5 teams, their top 5, their favorites, who will go on to join the Undaunted Accelerator program. It's very exciting. So I would love to introduce our judging panel here. We have 4 experts from across the industry, starting with the lovely Dr. Genevieve Hodgins. Dr. Genevieve Hodgins works at Supercritical, holds an engineering doctorate in carbon capture and storage and cleaner fossil energies from the University of Nottingham. Genevieve has almost a decade of experience in carbon sequestration with a focus on biochar. She currently leads scientific efforts on CRS pathways at Supercritical, at CDR Marketplace, and was previously the manager for the GGR-D biochar demonstrator. Welcome, Genevieve. Thank you for being here. Next to Genevieve, we have Maiko Shafrat. Thank you. Head of the Greenhouse Accelerator program at Undaunted. He has spent almost half a decade in the impact ecosystem and has built a community of more than 3,000 entrepreneurs and helped hundreds of founders solving the world's biggest issues. Thank you for joining us, Maiko. And on the other side of the room, we have Michael Hudson, who has led large-scale renewable energy and carbon market projects across Africa and Asia, bringing deep expertise in project development and climate finance. He's now an early-stage investor with the Oxford Seed Fund, focused on pre-seed and seed-stage startups, and is an associate fellow at the University of Oxford. Thank you so much for joining us, Michael. And our final judge is David Heitch, the head of energy at Innovate UK. He has worked in technology development and innovation across the energy sector for the past 19 years. Thank you so much for being with us, David. Okay, so these are our judges. They're going to be listening carefully to all the pitches just like you. They're going to be asking their questions once the pitches have finished. And at the end of the day, they're going to be deliberating and choosing their top 5. The notes that they take while they're listening to the pitches will also be shared with the startups as a way of feedback and learning. So, are we ready? Yes. Are you sure you're ready? Yes. Okay, excellent. I would like you to very warmly welcome our first team. Let's hear it for Ventrix Labs.
Hi everyone. We're here to talk about carbon, but we're starting the presentation with the supply of CO2. So at Ventrix Labs, we are building a decentralized CO2 supply chain with our hardware and infrastructure. So probably to your surprise, the CO2 supply chain is actually declining by 33%. And this is due to a variety of reasons, due to the current industries that are supplying CO2 as a byproduct are either shutting down or they're injecting CO2 underground because the governments are more incentivizing in that area. And we spoke to 170 different customers, and CO2 as a merchant product is already very, very expensive, and their customer could be paying anywhere from 2,700 pounds per ton of CO2. And we found out that 87% of that cost actually came from transportation. So this is where we come in. We're building a decentralized supply hardware and infrastructure to be able to transform local exhaust into resilient CO2 supply chain. And our patent is based on the mid-system modularity, which just hasn't been done before, that we are putting carbon capture units into a fridge-size unit and to be able to puzzle them together like Legos. And because of that, we can deploy and install within 3 days, and probably the quickest way to install a carbon capture unit in the market. And because we're also cutting the transportation costs, we cut 87% of the costs for our customers. Now, this is just a start. We're also utilizing the kind of waste resources within the local ecosystem, such as existing infrastructures, to be able to bring down that cost of capture from potentially $150 to $70 per ton of CO2, starting from today, and we can achieve that in year 3, such as the waste heat that we're leveraging within the existing building infrastructures. So at scale, where we're building is a infrastructure. Let's say we're capturing CO2 from breweries, and we capture excess CO2, and that could be trucked to nearby hospitals, pubs, or concrete plants to make low carbon concrete. And because we're tapping into both of these two markets, we can achieve both reduction and removal impact. This is where we at with our technology today. We're putting our TRL5 unit into the brewery. On the left, you can see we're setting up some bench testing to help our customers to understand how much money we can help them to save and how much carbon we can help them to avoid and reduce. And tapping into both the merchant and the removal market, we're focusing on the merchant market for now, where we're having the reduction impact, and that in itself is $5.3 billion market. And on the second layer of the TAM, which is low carbon concrete market, we can realistically help with a 2.17 gigaton level of untapped carbon that's currently in the built environment from gas boilers, energy generation plants, and biogenic sources to be able to feed into the lower carbon concrete market. So we're starting with the breweries in the UK first, and some hospitals, and that together adds up to over 100 million as a beachhead market. In terms of the next couple of years, we're starting with some pay pilots. So we actually recently started working with the NHS to install a pilot in 2026. We're also working with 2 other breweries on our pay pilots to be able to supply CO2 for them and cut all of that transportation emissions as well as the current emission directly out into the air. In the next 2 years, we'll focus specifically in breweries and some I can't really see. With breweries as well as lighthouse customers who can purchase multiple units at once. In the next year 4 and year 5, we will enter mass manufacturing. This is when we manufacture around 4,000 units to be able to distribute it within the built environment as well as small to medium-sized industries. And we can achieve 100 million AR in year 5. And our potential exit is to sell this to the brewery equipment company or asset developers who are able to use our technology to be able to further decarbonize. In terms of traction, we currently have 7 LOIs signed. Customers have been saying our solutions, especially within the brewing industries, are too good to be true. NHS specifically has said that they have a couple of gas boilers that they are struggling to get rid of because of the grid problem in the UK. We're also very proudly funded by Innovate UK to start our first pilot in Wales for breweries. And our business model is renting the units, literally just charging them on how much CO2 they're buying from us as a rental model. A perfect team to do this. We have a combination of hardware and software team to be able to carry out the hardware development as well as the infrastructure for the supply chain that's needed. And we have advisors with decades of experience in energy transition, commercializing climate technologies. And our pre-seed is open, and we are currently raising to deliver pilots and 5 pilots. And at the end of year 2, we should be achieving 2 million AR in year to achieving 2 million AR. Yeah.
Thank you so much. Well done. Well done. Thank you, Ventrix Labs. Very interesting. Hello, welcome. So we have 5 minutes of questions from the judges. Who would like to start us off? Don't be shy, judges.
Is this on? Great. Can you go a little bit more into maybe the opportunities for CO2 outside of brewing and how you're planning on kind of integrating with the low-cost cement industry?
Yes, so right now we're kind of taking a cross-vertical approach. We are in a pre-seed specifically, we're working with breweries, hospitals, and wastewater treatment plants, as well as working with some downstream mineralization company to do pilots, as well as establishing business case. Specifically, we're in the next 2 years, we're working on R&D to bring down the cost of capture, potentially down to 70. The theoretical minimum for us is $42 per ton of CO2, and we're working on that R&D process to bring down the cost curve. Yeah, right now we're just trying to integrate across different verticals to be able to have that customer base first to encourage adoption of carbon capture and utilization and storage.
Thank you very much for the presentation. I had a follow-up question actually around go-to-market. If you could walk me through what differences you anticipate between working with breweries, which is your beachhead, to moving over towards cement. I imagine there's differences in the scale of emissions and the supply that they need, and I would be curious for you to comment as well on the trade-offs that you make to achieve modularity and mobility in your technology.
Yeah, I can start with that question. We are currently, within breweries and wastewater treatment plants or gas boilers within hospitals, they have different concentration of CO2. Our technology currently has this patents to be able to handle different input purity, so it can move across different verticals very easily. The modular part makes it extremely easy to manufacture and to potentially add different subsystems to be able to handle the different purities. And when it comes to concrete, for example, there's precast versus ready mix. And ready mix itself currently kind of requires a lower quantity of CO2. We're talking about 20 to 7 tons per year. So we're starting with that market first. When it comes to precast, the really good advantage of us is being located near the demand sites. So we're talking anywhere from between 7 to 70 kilometers. That was relatively closer to the urban environment versus where you currently get CO2 from thousands of miles away. So we cut potentially up to 87% of that transportation cost. So that for us is the kind of biggest leverage when it comes to supplying our CO2 for concrete companies to be able to successfully encouraging adoption in the construction companies. We're currently also talking to Waits to try our technology and try to integrate within their value chain to be able to to make this business case really solid.
Thank you. I wonder if you could comment on the permanence of the storage for your technology and the customers that you're taking on the demand side.
Sorry, what was the question?
The permanence of the storage of the CO2.
Yeah, so when we're dealing with merchant market, it's more on reduction. What we estimate in terms of impact is the one-to-one swap plus the transportation emissions we're saving. So for example, hospitals are currently buying CO2 from VOC, for example, and then they're also emitting CO2. So we're cutting that in half, so they only have one. And then they're also saving on the emissions. But when it comes to concrete, the permanence is pretty much, you know, dependent on our downstream companies that we're working with. Yeah, that's I guess like an industry level question for them.
All right. I know you guys pretty well, obviously, so I held myself back. On that question of permanence, what do your customers say about this, right? How do they think about this? Because there's alternatives that they can consider and how to deal with their carbon.
Yeah, so for us, when we're speaking with downstream customers, their biggest problem is actually supply chain for not only CO2 but also waste. So we're tackling, you know, one part of it to be able to help them to scale. The biggest problem is to not have kind of concrete, reliable supply of CO2. We're trying to make that cost. The kind of quote that we've been working with other startups, like as long as it's below $100 per ton, they can do that at scale. So we're working towards that. We're currently around 150 at the moment, as we're R&D on more waste heat. So we're very confidently can bring that below 100.
Thank you.
That is all we have time for. Thank you so much, Ventrix Labs. Well done. And thank you to our judges for your questions. Excellent. Okay, one down. Let's go on to the next one. Everyone feeling good? Okay, great. Let's hear it. Oh, so sorry. Bit of slide management here. Here we go. Okay, now we're ready. Now we're actually ready. Let's hear it for our next presenters, BSC.
Hi, everybody. I'm John Mosley. I'm the director of BSC Separation Technology. I'm a chemical engineer by background. I've spent all of my career in process separation technology markets, and the last few years we've been working on the development of our new super compact separation technology. The base technology on the left, the super compact multi-phase separator, is a high G turbo-powered separation device that we've been working on for the last 6 or 7 years. It's now at TRL 7. That's a full-scale field test unit built this year. We've been testing. And on the right is our super compact mass transfer turbo-powered device that is taking the base technology and then applying it as a super compact mass transfer device. So how does it work? It's literally revolutionary. It revolves. And if you look at that tube, long tube acting as a centrifuge, there's no external motor. It's powered by a turbine that's built into the tube. So you're getting the spinning of these and centrifugal forces based on the fluid that you're putting through the unit. So it's a rotary high G separator, no motor, powered by a turbine, and then that enables you to put multiple tubes inside a vessel to give you a compact separation device. My background is oil and gas, so in the oil and gas industry, a large separator, such as the one on the left there, can be compressed into something about 10% of the size and weight. So there's a massive impact on compressing your technology. On the carbon capture front then, we're looking at replacing a large tower such as that absorber on the left and doing the same job or more efficiently in our device would be 10% of the size and weight, slightly bigger than a telephone box. A bit of timeline then. In 2019, our company and technology was selected to participate in the Net Zero Technology Centre in Aberdeen on their TechX Accelerator program, which was supported by BP, KPMG, and Equinor. We had a bit of a slowdown during COVID, But in 2022, we got funding for a project which is valued at about £1 million to progress our technology, backed by 2 oil companies and 2 industrial partners. And all the development, the test work was done at Robert Gordon University. So the full-scale test unit was built, 6 months of testing at RGU, a lot of analysis, and all our expectations and superlatives, we met and exceeded all those expectations on the compact and high efficiency. So in this last year, we built a full-scale field test unit. That's been offshore with me earlier this year. It's going back again in December on a live application. That's rated for 40 bar actually. So that's TRL 8 or 9 now. So on the carbon capture front, at the same part of the same program, we got a feasibility study done by a noted university, confirming the technology. This last year, we have done a basis of design for our full-scale test unit. The outline mechanical design is completed, and we're ready for testing on a test loop next year, and then field testing. So TRL levels, the carbon capture front will come right up in the path of what we've already done on our base technology in the next 12 months to TRL 7 or 8. We got patents granted worldwide for our base technology. Are you interested? Ask me any questions or see me later. That's me done, and I beat the time.
Well done, thank you. Excellent. Before time, that's exactly what we need. Thank you. Wonderful. Over to the judges for more questions, please.
I've got a question for you. Who are your customers? How does your business model work? You talked a lot about the tech. You seem to have something pretty special, but talk about the business model and the customers.
On our customers, our base technology is a super compact multi-phase separator. Then our main market's been looking at oil and gas separation, but the mass transfer side, anywhere you need mass transfer, there are our markets. On the carbon capture front, if you're considering a process where you're taking CO2 out of your gas stream, and obviously the obvious conventional way is using a solvent of some sort, then we can replace that big tower with something the size of a telephone box. So,
do you see any patterns of customer segments that are most interested initially, where you get the most traction right now, the beachhead segment?
Sorry, could you say that again?
Where do you see the most traction right now in terms of customers?
The sweet spot is actually where the gas pressure is, the higher the better for our technology. So higher pressure gas streams is our sweet spot. Part of the hydrogen process, by the way, in the steam reforming process, there's a high pressure gas stream with CO2 in, that's a target application for us, for example.
I had 2 questions that, in my mind, are related, but may not seem so. One is, I didn't pick up there too much on what the team looks like to deploy over the next, 12, 18 months. What does it look like? What's the team in place now? What does it look like in the future? And then something to follow on from what was asked around not business model, but revenue model. Is this a license play on the IP, or is this that you're in-house delivering the installations?
Good questions. We've got a very small team. The team we've been working on is a group with myself and university-based consultants and expertise. So a small team, but leading to that team, my commercial model has always been to license the technology, not to create a company that's going to take over the world. So it's definitely a licensing model.
And I guess just to follow on to that, when you think about the team, given that it's licensing, given you're going through the pilots and understand what the use case is there, what does your team look like in the future that it doesn't look like today? Like what are the team members that you need in 12, 18 months?
I'm doing too much of the work, so I definitely need a project manager. So that's the key discipline. But our base design team that we've got, it's actually building the unit and project managing that exercise is what we need. But we're kind of ready to go on that mass transfer carbon capture front. We've actually got a contract in place with the university. We've got a test loop ready to slot our unit in. So we are ready to go. And we've also got the backing of one industrial partner as well.
Could you say a bit more about that?
No. Speak to me later.
When it comes to the downstream CO2, do you have anything, is there anything within this technology with regards to purity or kind of the gas that comes out that you need to control or be aware of when it comes to sequestration particularly?
Yeah, the base technology we envisage is the solvent-based extraction of CO2 from a gas stream. Our technology has advantages over a number of alternatives, one of which is that absorption process into the solvent. There's a heater reaction when you do that, and that affects the efficiency of the process. And one clever trick we've got in our technology is we're able to cool the fluid and therefore make the whole process more efficient. So there are some natty little tricks within what we've got.
And then I suppose on the upstream side, are you restricted to high concentration CO2 sources, or would you be able to integrate this with kind of DAC or anything like that?
I can't, could you say that again?
Sorry, when it comes to your CO2 stream that you're separating,
yeah.
Are you restricted to high CO2 mixtures, or can you do that at low CO2 percentages?
I think I may answer the wrong question, but we've been looking at gas streams containing up to 30% CO2 down to 2% CO2, and everything in that range is treatable.
Awesome.
Did that answer your question? Okay.
That's all we've got time for the questions. Thank you so much. Okay, our next startup is joining us remotely. So we're going to have a little bit of a technical switch, and they're going to appear. Oh, look at that. Oh my gosh. Welcome.
Hi.
Hello, Ellie, over to you from Blue Sync. Let's hear for Blue Sync.
Well, thank you. Hi, everyone. I'm Ellie from Blue Sync, as just mentioned. I'm here today virtually to talk to you about ocean carbon removal, which I feel like the background to this slide might have given away. So, ocean carbon removal. Oh, my slides are changing. There we go. So ocean carbon removal has huge potential, but at the moment, both the engineered approaches and the blue carbon approaches have somewhat of a reputation problem. So typically engineered ocean carbon removal pathways are seen as a bit controversial. You can see that in some of these headlines. They can be criticised for not working in harmony with nature, and they've come up against community resistance, probably because it's hard for people to visualise or understand the benefits. This background photo is from an ocean carbon removal trial in Cornwall. Likewise, blue carbon approaches are important for their ecosystem benefits. They're favoured by local and small communities, but they don't really have the backing of corporate CDR buyers yet due to questions on permanency. So at Blue Sync, we're aiming to solve that problem. We're bridging the gap between engineered carbon removal and blue carbon ecosystems, and we're offering a more holistic approach to ocean carbon removal that maintains the durability of engineered approaches, combining this with a way to address ocean resilience problems and simultaneously revising seabeds and sequestering carbon. So how do we do this? So first of all, we increase alkalinity through the action of our mineral units. I've got one here, if you can see on screen, which we call blue synkies. And what they do is they raise the pH of the surrounding water column and subsequently provide space for CO2 drawdown, similar to traditional ocean alkalinity enhancement projects. The deployed units, like these, then sit on the seabed, creating a strong habitat with the localized pH effect providing resilience against changes from ocean acidification and offering a safe haven for marine ecosystems. The units act as an artificial substrate for a variety of species, including coralline algae, a species known to support blue carbon sequestration processes by trapping organic matter and by themselves transforming carbon from the seawater into more stable geological forms. Crucially, coralline algae, if you don't know them, are a habitat builder, and they provide support to a variety of other marine species, so over time a thriving ecosystem emerges. This approach ensures that we maintain the efficiency and the durability, and therefore commercial interest from CDR purchasers, of more engineered approaches, whilst also actively supporting ecosystem restoration strategies and giving the community something they can visibly see as having a positive impact. We measure our impact through a combination of deployed in situ sensors, modelling, and for the biodiversity photogrammetry. So far, we've conducted lab research, deployed at 6 small trial sites around the world, and we have ongoing research partnerships with some leading institutions. We are planning for a scale pilot in 2026. Our go-to-market strategy relies on our biodiversity and restoration benefits as an access mechanism. So business and NGOs can lead the way to deployment by investing in restoration projects first through CSR initiatives and in order to make their own contribution claims. Then governments see the traction through these projects and begin to pave the way for permitting and sales to CDR. Eventually, our business model transitions to the sale of offsets directly on the voluntary carbon market through registries and brokers, etc. And this approach, this restoration, like supported by businesses and then backed by government later, is an approach that we've seen validated in parallel markets, for example, through seagrass project deployment in Indonesia, which started with funding from corporate backers, got the government interested, and now is in piloting for permitting for future CDR projects. We've also then tested this approach with some potential future partners whose logos are at the bottom of this slide. Our business model focuses on the sale of the 2 products, so carbon removals in the long term, but also our restoration as a service offering. Because the MRV for the restoration is really compelling and because the results are visible to the human eye, the complexity to explain the benefits of this service to future buyers is much, much lower, which means we can sell restoration right now with minimal additional investment or R&D required. This then allows us time to further validate and scale our CDR, generating revenue through restoration, whilst we gather further data on our capture efficiency in different regions and validate this with the wider MCDR community. We've specifically designed these Blue Sinky units to be modular, meaning that they can be manufactured at a range of different existing facilities contracted out and deployed in areas of varying sizes. This means that the majority of our costs actually comes from deployment and monitoring, which becomes significantly reduced the larger the deployment site, which is what you can see on this graph. So this is the forecast cost to deliver 1 tonne of CO2 removal, which rapidly decreases with scale as the project size increases because of the efficiencies of monitoring, etc. Our team brings together scientists, engineers, and practitioners who've already delivered CO2 removal projects in the real world. And this means we understand not just the science, but also the operations, the permitting, and the on-ground challenges. At the moment, we're looking for a proof of concept site. Ideally, we need this to be around 200 square metres in waters between 0 and 25 metres deep, with a clear route to permitting and reliable access. Just as important as the site itself is the chance to work with the local community, so we'd love to involve divers, fishermen and women, swimmers, surfers in the project, making it not just a scientific trial, but a shared effort to restore the ocean together. So if you are able to help with that, have any ideas for that, then please get in touch with us if you think you can help. Thank you so much.
Thank you so much, Ellie. Over to the judges for questions for Blue Sink.
Thanks, Ellie. Just thinking about the scalability of the technology, can you give an indication of what a commercial size, let's call it a plant, space it needs for that, and where the sites might be?
Absolutely. So we can do anything from, literally square meters to hectares. Our ideal site is no less than a hectare when we're at a scaled kind of size. And that is purely because of the investment that we have to do into the in situ sensors, etc., which can capture about a hectare's worth of data, but like are expensive to deploy. So ideally a hectare, and then anything upwards, we can talk 10 hectares, whatever else. And that's kind of the point of this, is that you lay it down on the seafloor and then you can lay it at whatever size. But for us to get to the efficiency that we showed on that cost curve, really the minimum size would be a hectare.
Thank you very much. It was a great presentation. To follow on from that, do you have any geographic restrictions on where this can be applied, specifically thinking things like climate? Does it work in tropical waters? But also, would it work in freshwater?
Perfect question. So in freshwater, it does work. The alkalinity effect is similar, but we try and avoid deploying it in freshwater because we can't guarantee the biodiversity benefits, and we don't know the system as well. So we don't know what will colonize it. The species that we're specifically targeting lives only in seawater. So for that reason, we try and do it in seawater. We could, as I say, do it in freshwater, but we just wouldn't have that ecological advantage that we think is the key distinguisher between ourselves and other alkalinity enhancement projects. In terms of geographical limitations and where we can go, essentially we can go anywhere as long as it's sort of got sunlight penetration in the seawater. So anywhere, depending on the clarity of the water, between 0 and 25 meters. It has a different efficiency rate depending on the water. I mean, oceans are incredibly complex, so you have to factor in the temperature, the starting pH, all of that kind of stuff, which is why we do baselining for each project. But the principles are the same, it's just the speed at which it happens. But because we then also have this regenerative sort of secondary effect of the biodiversity and the carbon capture through the ecosystem, that continues for multiple years. And so we can monitor sites for longer and therefore get the same capture efficiency overall. It just depends on the kind of baseline starting point. But there are no limitations in terms of geography. It's just then a calculation of the efficiency based on that geography, if that makes sense.
Can you elaborate a bit on the restoration as a service business model and the demand that you're seeing and the challenges that you might have to overcome with that?
Yeah, of course. So the restoration as a service business model is basically based on the fact that we know that we have results from different university studies and live deployments that the main species that colonizes this is, as I said, a CCA. That CCA is really, really well known in scientific literature for helping other species, specifically corals and seagrasses, with their resilience and with coral seeding. And so the demand that we are seeing at the moment from the restoration side comes actually primarily from coral reef restoration projects, where they're looking for technologies to enhance either the seeding or the resilience of their coral projects. And any coral reef scientist knows that crustaceous coral and algae is important for the settlement of coral. So we have co-deployed with a couple of different conservation initiatives for that specific reason. More broadly, we're seeing a demand, I have to say more in Southeast Asia than in Europe, but in Southeast Asia for restoration projects that are more holistically looking at the seabed. And then there's similar examples. For example, in Denmark, there's been quite a big push towards stone reef restoration, and that's not dissimilar to this. So we're seeing quite high demand. Our model is basically based on a square meter costing, which is what other restoration services, for example, coral reef restoration or stone reef restoration, are doing, is charging based on the kind of project size. So that is our model there.
Thank you. Just one last question. What lesson do you take when you think capital raising pathway and market readiness from the narrative of Running Tide, their experience as someone who's looked at the space?
Yeah, excellent question. We're very aware of the impact of Running Tide on the industry and in terms of capital raising, etc. So I think that one thing that we are very keen to communicate is that there is a variability in any ocean-related project based on the kind of circumstances of where you're deploying, and the baselining and then the ability to forecast from that baselining is really, really important. And when we talk, if we're talking about capital raising or even selling or whatever it is, when we talk to people, we make it very clear that all of our modelling and our estimates and our lab results and our analysis is just a forecast, and that we have to be very specific about the location and then what that means in terms of CO2 capture and also permanency, because the biodiversity impacts might vary based on like the respiration rates, the photosynthesis rates, etc., in different areas of the ocean, and that all has to be factored in to then the overall total carbon removal. And when we talk to certifying bodies that we're talking to, for example, Isometric, that's something that distinguishes us from OAE and also the blue carbon, which is we have to factor in both of those things. So it's a slightly more complex situation. But we just, I think our learning is just to be really transparent in what we know, what we don't know, how we test, and how we gather data to validate, basically.
Thank you very much, Ellie, for joining us. Can I ask if more people in our audience, or indeed the judges, have more questions for you and about BlueSync, can they get in touch?
They absolutely can, yep. So I think if you scan this QR code, it takes you either to our website or to my LinkedIn. I can't remember which one. But if you scan it, you can find us somehow. You can also find me on LinkedIn, or my email is on our website as well. So there's many ways to contact, and I'd be more than happy to answer questions or speak to people.
Thank you, Ellie. Can we get the QR code back on the screen, please?
Ooh,
We have your face, which is wonderful, but it would be nice
that's actually me to share this. Let me just share this 1 second.
Okay, in the meantime, let's hear it for BlueSync and the presentation from Ellie. Thank you very much. That's if you want to get in touch. Okay, we have one final pitch before a break. Please welcome, with the warmest round of applause yet, Crop Intellect.
Hi, everyone. So, we have been talking about carbon all day. Now we're going to talk about N2O. My name is Álvaro. I'm the COO of Crop Intellect. And I know that carbon removal is difficult, but you should try N2O. N2O is difficult. So today we're going to talk about a solution to a problem. And the problem is that food systems work basically on using the land, and the land needs fertilizer, and normally synthetic fertilizer, and that are emissions of N2O. Okay, so 60% of man-made N2O emissions come from agriculture. So today, everyone's trying to help and trying to do something about it, but everyone's trying to avoid, trying to reduce synthetic fertilizer use, trying to get low-carbon fertilizers. But we have developed a technology that is a foliar spray. It's very easy to use for farmers. We have tested in farming environment for the last 6 years. And as you can see in the leaves up here, this is a foliar spray that contains a mineral called titanium dioxide that has photocatalytic characteristics, which means that when interacting with gases, react and make two processes. In the one hand, and you can see on the bottom, let's start in the bottom, it's able to break down NOx pollutant, specifically NO2, into nitrate. Nitrate stays on the leaf and then gets solubilized with a little bit of water or moisture, and then it's a fertilizer. And with this, we could have plenty, and we could be a very good fertilizer company, low-carbon fertilizer, but it's a very busy market, and it's difficult. But our material has a unique selling point, and it's the removal of N2O, and effectively destroys the N2O permanently, and it's a process that doesn't come back naturally to an N2O again. And N2O is around 300 times more potent than CO2, and we have been able to demonstrate a potential impact between 2 and 5 tons of CO2 equivalent per hectare per season, meaning that we, at this point, were one of the unique solutions in agriculture to really tackle N2O. But who are these people? Why are they talking about N2O? Who cares? Let's go a little bit more in depth. Our company is Crop Intellect. We have been funded by Breakthrough Energy, the European Commission, Innovate UK. We really bring in something to the market that is unique, and we have been able to test as an agricultural input for the last 6 years, being able to show an increase of yield, a reduction in synthetic fertilizer use. So we don't have barriers to entry the market in terms of agriculture, because farmers are happy to use the material. How is our business model? We sell the product. We have our leaf as a product that farmers and the supply chain can buy, and they can apply, and they can obtain the material, the benefit both at fertilizer level, but also at N2O removal level. So we are a product-based company, period. We can produce at 5 pounds, we can sell at 15 pounds, we can produce at scale. So we have solved all the questions about how the business will work. But why the N2O is unique? And it's because we are the first company that is actually destroying N2O at a scale. And we have been able now to validate our methodology under ICRO-endorsed registry, ICR, and sustain third. So that means that today our companies can actually capitalize on the removal, both in the way of carbon credit, potentially, but also in the reduction of carbon footprint in the supply chain. Meaning that, business-wise, we can really help our customers however they decide that they want to move forward in their decarbonization journey. Who cares? In the supply chain, the farmer wants to increase revenue, want to be more profitable. They try to be resilient against volatility of market and prices going up and down. And in the insetting market, everyone, the supply chain, meaning Unilevers, InBevs, Tesco's, etc., they want to reduce carbon footprint, but it's expensive, and they have to change a lot of things in how they do things. We bring all of them one solution that helps them in the different needs that they have. We are at this point where we have answered all the technical questions. We know that we can remove N2O. We know that it's validated under ICRO-endorsed registries. And now is the moment to scale. Now we have to model the removal, so we don't have to be measuring constantly in the field, because logistically complex is not expensive, but it's complex. So the idea is that now, in the next season, we're going to have 15,000 hectares developing a machine learning-based model, because this season already, in 2025, we have developed 5,000 hectares, but we want to scale. We want to do more in order to be able to have a model that simplifies things in order to scale. This is the team. We are ready. We have all positions covered, and I'm almost done. And we're raising capital, but mostly what we need, guys, is you. We need the community of the carbon removal to help us, because we are the underdog. So if you guys, the judges and the public, if you really want to support the underdog, we are the underdog. We're trying something difficult. Okay, thank you very much, guys.
Well done. Thank you for that. Thank you. Thank you so much. Questions from the judges?
Thank you very much. So what is your kind of specific monetization strategy here? Like, are you selling carbon credits? Are you selling this material to farmers?
Yeah.
Like, so you're selling to farmers?
Yeah, we sell product to the supply chain in general, meaning that InBev is interested in investing in technology so farmers can use it, but the farmer is also interested because they want to access premium contracts. They want to understand how they can reduce their carbon footprint because they're interested in monetizing carbon credit. So we don't participate in the removal. What we do is only support with the sale of the product, but help them in building the projects as well. But our monetization structure is only selling the product.
Okay, awesome. And what is, compared to the kind of profit margins on those yield increases that you're seeing, how is the cost of the product?
Yeah, so today, for example, the cost of the product is only £5, around that, to produce 1 liter. We recommended 2 liters of our leaf per hectare per season only, so it's very easy to apply and very scalable. And we can sell between £15 and £25, depending on what the client needs. If they only want the fertilizer, they can buy at 15. If they want a full project developed, they can buy at 25, 27. So we included in the final price the cost of developing a project so they can reduce the carbon footprint or can generate credit. So we have embedded in one pricing structure with different tiers so they can follow the path that they decide.
Okay, so just to clarify, the product doesn't directly increase yields for farmers, or it does?
It does.
It does.
It does.
Okay, is that the main reason for them to buy it, or what's the main reason, and what are barriers? Just a follow-up question. Yeah. What are barriers for you to actually scale this and farmers to want to buy this?
First of all, sales cycles in agriculture are very long. Okay, farmers normally they will try 2 hectares today, 5 tomorrow, and 300 in the future. So it's very complex. So what incentive they have in order to use our material and no one from Corteva or any other product, low carbon fertilizer. So our unique selling point is like, hey, if you buy ours, in addition to your fertilizer and your potential increase of yield or reduce N, depending on the season, because farmers also decide season on season. So they might be so into synthetic fertilizer reduce, and they say, it's going to be a tough season, I'm not going to take the risk, so I'm not going to reduce, okay? Meaning that what we say is like, okay, this season you have decided not to do it, you can buy, you can increase your yield, and you're going to get 2 to 5 tons of CO2 equivalent removed per hectare per season. That's our unique selling point, okay? Yeah. And sorry, barriers? Yeah, we have been 6 years in the market already trying the product. We have not seen toxicity. We have not seen issues with application. So far, farmers are happy to put it, but we need to give them reasons why to choose us instead of others.
That's a good segue to my question, actually. Farmers are notorious for being conservative in their decision-making. They have very limited chances to harvest over their lifetime in any setting. So what have you learned around their questions to you, and how have you sold this to them, given that you're also not mature in the MRV side? And then my follow-up question to that is, how do you access the market? What partners are you thinking to work with to access farmers where they're at and who they're listening to?
Yeah. So for farmers, the essence is it needs to be easy to apply. It cannot disrupt their normal activity. And for that, we have a protocol that follows their own practices, so we don't change anything for them. Second, the cost. We cannot be a cost that is beyond what they really want to have in terms of operations. Because if you are out of market in terms of as a fertilizer, the carbon footprint needs to come from the supply chain, meaning that they are selling the product to Tesco or to a packer, and they need to understand that the economics work for both parties. So Branston, for example, as a company, as a packer, will put extra money for the farmer to put our material because they're interested in the carbon footprint being reduced. But the farmer, what they're interested is in the economics of their unit and to secure the contract with the packer, with the Tesco's, with the M&S, et cetera, et cetera. So that's why it's important that we keep always the farmer at the center to solve their issues, okay? Did I answer the question? Okay.
Well, yeah, just as a very quick follow-up, I've seen other approaches which work with universities for demonstration and extension in the US and in Europe, and just understanding how you're going about partnership building for demonstration.
Yeah, on that, we're working mostly with the top of the supply chain. Again, Marks and Spencer's, Tesco's, Packers, they have the influence in the farmers in order for them to make decisions about what they put or not in the farm. It's not a decision that they're going to force them to do anything, but they create incentive programs. So then they can benefit all of them, the supply chain, but also the farmers, in order to move beyond and to move toward decarbonization activity. Yeah, and today we're working with all those partners, again, InBev, Tesco, Helena in the US, so a number of top partners so they can have the influence in their farmers.
That's all we've got time for. Thank you so much. Perfect, thank you.
Thank you.
We have 4 startups pitching in this next session. But before we get into that, we have another keynote, and I am really excited to introduce Elisa Gilbert. Elisa is an all-round expert on environmental and climate change policy and science. She has a wide-ranging experience as a science communicator, manager, salesperson, and environmental consultant, specializing in energy and climate change solutions. She has specific expertise in emissions trading systems and market readiness, but with additional knowledge on a broad range of topics, ranging from avoided deforestation through climate finance to adaptation to climate change. She's the Director of Innovation at Grantham Institute and Undaunted, and also co-director of the School of Sustainability at Imperial College. Please join me in welcoming Elisa Gilbert. Thank you. Either mic is fine.
Okay. Can you hear me all right? Yeah? All right, that was quite a long, complex introduction. But basically, for the purposes of today, and right now, I'm the director of Undaunted, which is an organization you've heard about a little bit already, and that's Imperial College London's climate change innovation activity. And we're hosting this activity here, and David, who's running this activity, works at Undaunted. What I'm going to talk about now, so Gabrielle, when she introduced, I love the idea, by the way, of having 3 keynotes. Is it the keynote? If there's 3 of them, I don't know. So for the moment, I'm the note that's playing. So the first keynote described a little bit, this whole broad challenge of CDR, talked about the fact that we're having the pitches and that the pitches, like 5 of the people who are pitching, are going to get to do something, basically. They're going to get a prize. they're going to come on what was called the Undaunted Accelerator. And everyone's like, yeah. Okay, so but basically, what's the prize? Like, who knows what that means, right? What does that mean? Like, normally, we're not giving them thousands of pounds and so on. So what's the benefit of coming on the accelerator? So what I'm going to tell you about now is, first of all, what are we doing at Undaunted? What does that mean to run a set of climate change innovation programs at Imperial, and specifically why we're doing something on CDR and what that special prize looks like. It's a bit unfair for the first pitchers that we're doing this now, because the second set of pitchers will now do so with much greater vigor because they realize the quality of the prize at stake. So when Gabriel showed you all of these opportunities actually in the carbon removal space, it makes it look as though all you need to do to seize the opportunity is to create a company in one of those buckets and then you're done, right? Well, in the audience, we have lots of innovators, so is it that easy? No, exactly. So as my predecessor, who was previously working on innovation, taught me, it takes really a village or a whole community to help an innovator to thrive. And actually, you need to have support, and particularly community, at all stages of your journey, from the very, very beginning, through to the point where you're retired and you're sitting on your pile of cash and you don't know what to do with your time. So at Imperial, because we're a university, we're really interested in the stages that start at the very beginning, the very beginning. So what I like to say is moving from science and discovery to solutions that can deliver real impact. So when we talk about our innovation programs at Imperial, we're talking about things that are hovering in that earliest of stages. So to call out a few other people in the audience, who's here from our new master's program in clean tech innovation? Okay, amazing. So these students started Monday, right? I actually hadn't had a chance to meet you yet, so great to meet you, and I'll see you next week in a classroom. But what's great is this is what we're talking about at the beginning, right? These are people who have life experience, work experience, or academic expertise and are enthusiastic about learning about entrepreneurship or finding challenges like those are being described today and going on a journey of innovation and entrepreneurship. So we do things that are education, and we do that also for some of our undergraduates and other non-specialized master's students at the university. So helping people enter the entrepreneurship pipeline is really, really important, and we also do that for people in our local communities where our campuses are. So we believe that it's really important to have a wide range of diverse innovators, the people who can bring these solutions to life, lie all across our communities, not just the people who are in our elite educational institutions. So that's the very first stage. But what's important and relevant to today and to the prize is the support that you give in the community. And so Maiko here runs our Greenhouse Accelerator program. It's one of the longest running activities that we've been doing at Undaunted. And it's been running for about 13 years. It's a dedicated climate change innovation accelerator program that helps take people from when they've got a bit of a tested idea or a prototype through to the point where they can get their first seed fund investment. But it's a generalist activity that we do there at the greenhouse. It supports anyone who has a solution that can either reduce greenhouse gas emissions, help us adapt to the impacts of climate change, or removals. And that's a really, really wide brief. And you can imagine how wide-ranging the solutions are that come onto this program. You already saw how wide-ranging the solutions are in CDR alone, right? So it's much, much wider. Even so, we found that a dedicated accelerator program builds valuable community, people of passion, and helps them support each other as they go through, despite having different technologies, very similar questions at similar defined time points, to the point where Stephanie and Maiko, who run the program, are able to almost schedule in support activities at dedicated points because they know that roughly those innovators will have the same questions at the same time, whether that's about founder agreements, or IP, or how do I meet customers, or how do I plan for my next investment round. Doing these things together as a group is very supportive, and having external advice is really, really valuable. So we've been doing that for a long time in a really generalized way, and I could go on about how brilliantly successful we have been in supporting 200 companies, and they've raised over $1 billion and employed 2,000 people in 30 countries and everything. But you know that's fine. The question is, what do we do next? And the answer really is to dive into specific sectors and say, okay, if just doing it for a passionate group of people who care about innovation and climate is so effective, how much more effective would it be if we focused on a subset or a substream of those people? Because then we can help them access specific client groups, think about sales and markets in a way that's dedicated to their sub-area. And so that's exactly what we're doing now for greenhouse gas removal. And with thanks to the funding from Innovate UK, which came together with the core greenhouse gas project, which we've been doing with Oxford, the leadership that we're able to put in place with David running a completely specific CDR program allows us now to select 5 people to give the prize to. And those people are going to get this specialist version of follow-on support. Well, they'll be able to still connect with the people that are in our innovation community, like the people that more generally Maiko and Stephanie are supporting in the greenhouse. But actually what they're going to get is some dedicated support to tackle the really, really knotty and specific problems in CDR. And even though all of the people that you've seen pitching so far today have really, really different solutions, some of their challenges are really similar. So if you listen to what Gabrielle was saying, you know, one of the things that's so hard is, where's the demand in this market? Where's the demand beyond Microsoft? 85%. That's incredible, right? But you can't grow a whole business on there just being one purchaser for 85%. So working together to think about markets whilst everyone's honing their own individual business model is really important. Finding the right mentors in this specific and relevant spaces, going on the journey together is really important. And I know David's very passionate about AI, so helping people use AI more effectively in their CDR innovation journey is going to be really great. He's helped me a bit with that as well. And then, you know, other specialist things that might seem like niche interests, but are really important to this sector, particularly, for example, insurance. How will that work in this area? Or that issue about monitoring, reporting, and verification, which is really important if you choose to go down the offset route, but also if someone needs to have, you know, credible removals, they need to have that certified somehow. So how are we going to do that? So just to make it clear, the prize is access to becoming part of a community that's really important in the growth of this business, and dedicated targeted support, really, really focusing on this sector. What we're hoping is that we'll learn something from this too. So as I said, we've got our general programs, and what we're really interested in knowing is what does it look like to tag on a specialist program into our portfolio? If we do it for CDR now, should we continue it for CDR? If we do it for CDR now, should we add it for other sectors? So it's a prize for you, but also a prize for us. That's nice. So with that, now that you understand what the prize is, you can watch with even greater enthusiasm to see who might be awarded this prize as the pitching continues. So thank you for joining us.
Thank you, Lisa. It's very exciting to hear about the prize. I am a little bit jealous. Okay, let's get back into some pitches. Are we ready? Judges, are we feeling good about this? Are we ready?
Yeah.
Thank you. That is the energy I'm looking for. Excellent. Okay. Without any further ado, let us all welcome, and I hope you haven't forgotten how we welcome everyone. I'm sure you've been practicing over the break. But let's welcome the next team to present, Remedium Energy.
Good afternoon, everyone. My name is Omid. I'm one of the co-founders and CEO of Remedium, where we're trying to make carbon capture commercially viable. But today, I want to tell you a story. Yes, I'm one of those guys. So come back with me to January of 2020. I was in my 3rd year of PhD. One day in the lab, I saw a new face, a visiting scholar from Canada. His name was Moji, and I was given a task to show him around Cambridge. So we headed out. I remember it was a sunny day. I know, sunny January, UK, sounds suspicious already. But believe me, it was sunny. We ended up at the cafe in front of King's College, talking, like our good PhD student, about our research. Because let's face it, as PhD student, we didn't have anything else going on in our life. Moji's PhD was on developing a new material for carbon capture. I was always skeptical of carbon capture. So I asked, Moji, why do we need carbon capture when we have renewable energy? Moji wrote down these 3 numbers. He explained that 20% of all CO2 emissions comes from industries with inherent CO2 emission. So these emissions can only be eliminated with carbon capture. But point source carbon capture is currently too expensive, $100 per ton, and 60% of that is associated with two things, material and energy. Then he showed me his material, lime loop, that can capture 36 times more CO2 over its lifetime than natural limestone, cutting the material cost by more than 80%. But still didn't know how to reduce the energy cost. I told him, Moji, I might have a solution for you. I explained that my PhD is on heat batteries. Moji looked confused. What is a heat battery? I explained a heat battery converts cheap electricity into heat, store it, and then convert it back into electricity. Moji looked even more confused. Fine, how does that help me? My answer, 4 words. Carbon capture heat battery. I explained that when we expose lime loop to exhaust gases, it captures CO2 and releases high temperature heat, which we convert into electricity. Later, we use cheap electricity and convert it to heat to regenerate lime loops, so it can capture CO2 again. Since the electricity we buy is cheaper than the electricity we sell using electricity arbitrage, we're not only reducing the energy cost, we are making money from it. This idea excited both of us and led to founding Remedium. And it all started on that sunny day. Since then, we have shown that our cost of capture is only $13 per ton. Tested lime loop for 100 cycle, reaching TR5, built a demo of carbon capture heat battery reaching TR4, filed 2 patents, participated in several accelerator programs, won international awards, and received a letter of intent. Beyond just a low cost, we provide food-grade CO2 sold at $200 per ton, and our process is waste-free because lime loop can be converted into cement after its lifetime. Our business model, our long-term goal is to build carbon capture plants for our clients through joint ventures with engineering firms. And to get there, we have 2 key milestones. Manufacture lime loop at ton scale and build a pilot plant. In short term, we sell lime loop to companies that are currently using natural limestone for CO2 captures, and in medium term, our pilot plant can be sold as a standalone modular heat battery for high temperature heat storage applications. This phased approach enables us to generate early revenue while advancing the 2 main aspects of our solutions. Our team present a balance between experience and expertise. We have 5 PhDs in engineering, 2 MBAs with more than 100 years of accumulated experience in relevant research, industry, and startups. And we are currently raising $1.5 million to do 3 things. Manufacture lime loop at ton scale, do a live fluid gas test of lime loop increasing its TRL to 8, and demonstrate the battery at kilowatt hour. By the way, here's a photo of me and Moji on that day. You see, I told you it was sunny. So now tell me, what do you do on a sunny day in January? You step outside so you don't miss it, right? Same applies here. If you're interested, please reach out. Thank you.
Well done, that was great. Thank you very much. Wonderful storytelling. Over to the judges for some questions.
I'd love to get some more insight into what your short-term market is, what you see the scale of that being over that short term, right?
So, yeah, I mean, in the short term, we're looking at basically companies that are providing calcium looping process, which is a process that captures CO2 using natural limestone. And then the DAC companies, some of them actually in the room today, that are using natural limestone to capture CO2. So we have done, obviously, estimation of what would be our potential revenue by selling those to those companies, and it is dependent on their being able to scale their technology, obviously, but we're looking at a TAM of $32 billion at a scale based on basically the carbon capture market and the fraction we believe that a calcium looping process can capture.
So is your model to to create and sell the tech, or is it to license the IP of it? What's the route to market there?
With the material, we're looking at outsourcing manufacturing and selling the sorbent as well. With the medium-term market, which is a modular scale heat battery application, we're talking about 20-foot container, similar outsourcing and manufacturing and selling it to potential applications where high-temperature heat or solar applications are relevant. When we're talking about the long-term market, which is our carbon capture market, we're looking at basically partnership, having joint ventures with both EPC companies as well as the point source, basically the point source plants like a cement, a steel, oil and gas plants, and develop these basically carbon capture technology and take a fraction of it as basically the fee for our development and involvement in that project. Yes.
One question, I'd love for you to spend a bit more time on the team slide to build out, because there was a busy slide there. I just want a bit more context on the roles of the various people. And then secondly, could you walk through in the short term who you see as your competitors as input suppliers to your short-term customer?
So the short term will be the natural limestone as a competitor. So any company that provides limestone would be a competitor as alternative to our synthetic limestone that we can provide. So lime manufacturers or basically those places can be a potential competitor. There is also a company recently we came across that develop natural limestone, but in a pellets format that claims to be able to provide thousands of cycles. So we're looking at those companies that are creating this pellet-sized natural-based limestone to be the main competitor for the short-term market. And in terms of the team, what was specifically the questions? As you can see, there are four main people that are our core team. All of us have PhDs in relevant basically industries, with Ahmed having more than 30 years of experience working for oil and gas companies. So he has the experience of scaling and working at industrial scale projects because that has been part of his work over his lifetime.
You talked about the short, medium, and long-term markets, and I'm interested in how can you kind of really scale fast in terms of revenue and climate impact when you have to kind of really establish yourself in these different markets over time, and what barriers do you see that you have to overcome to scale fast?
So I think the main barrier with the scaling any carbon capture technology has been its long development, deployment, and sales cycles. That's something that is a struggle with any carbon capture technology, and that's why when we identified the long-term market, we identified the potential short-term and medium-term market in between that can provide revenues. So as you can see with our pre-seed round, our main focus is on material development. We are focusing on basically achieving the first target of manufacturing this at ton scale, because that's going to be the relevant amounts that would be needed for basically doing a project. And after that, we're looking at developing the next stage of the technology, which is a pilot plant. Unlike most carbon capture technology, where a pilot plant will become a stranded asset, because we have this dual function of the heat battery and a carbon capture, we're looking at selling this and converting it into a product. And that one, we have seen lots of traction, similar technologies, the heat battery technologies being developed. So because we store heat as a chemical energy, we can provide more compact solution compared to the competitor. So we can see that compactness, especially based on discussion I've had with several industries, is very important. They are limited in the space in the plant. So that's going to be where we excel.
Thank you.
Thank you so much.
Thank you, well done.
Great start to the pitches in the second half. We are now going to transition back into the world of remote pitching. We have Team Capture, should be on the line. Excellent. Let's welcome Capture.
Good afternoon, ladies and gentlemen. I assume you can hear me. My name is Adam Samuel, and I'm co-founder of CapChar, and we are pioneering a rural heating revolution powered by biochar carbon removal. So our customers are rural businesses, and they are a sleeping giant that contributes 15% of the UK economic output. Rural businesses face significant pressures with rising input costs. Heating is a pain point, being a significant cost centre that has had very little innovation in decades. Current heating options are grid limited, price volatile, or they use unsustainable fossil fuels, and switching technologies is expensive. Worse still, none of these options lock up any carbon, leaving no climate-friendly opportunities or economically viable choices. CapChar transforms heating from a cost centre into a profit centre by allowing rural enterprise to use on-site diseased, damaged or waste wood feedstock as a fuel. I want you to take away 3 key points from today. Our patent-pending biochar heat battery system using batch pyrolysis technology makes us 10 times cheaper than continuous systems. In 1 year, a typical 4 cubic metre system would produce 100 tonnes of biochar and remove 200 tonnes of carbon dioxide. A cubic metre battery will store 95% of the waste heat from the process, capturing 120 kilowatt hours of thermal energy. Process heat reduces feedstock moisture content to less than 10%, ensuring a clean, efficient combustion and lower carbon emissions. Crucially, the stored heat can be steadily discharged at a much lower temperature and time shifted, offering carbon negative heat on demand. CapChar's transportable and modular technology avoids lengthy planning permission delays, offering a homegrown opportunity to build a biochar network, creating local jobs and decarbonisation. Customers buy our hardware and use revenue generated from carbon credits, delivering a 3-year ROI. Our business model does not rely on selling biochar as a commodity. For a recurring fee, carbon credits are issued using our own digital monitoring, reporting and verification software platform, biochar carbon code and registry. Removing the middleman lowers costs, enabling mass adoption by smaller operators who can generate their own carbon negative heat and removals nationwide. So why are we the team to make this happen? Well, we've been building businesses for over 25 years. Chinton brings operations strategy, marketing and project leadership. I'm a mechanical engineer and biochar expert. And we're joined by pyrolysis veteran Ian McChesney, who's been building these systems for decades. So we've raised over £700,000 in public grant funding since we started. And we aim to be commercial within 9 months with 3 to 5 paid pilots by the end of this year, adding to our 2024 funded pilots. The goal is to convert 20% of our customer waitlist in 2026. Biomass boiler replacement is a £500 million UK opportunity. 17,500 rural businesses installed a biomass boiler heating and relied on the now scrapped RHI payment to subsidise the fuel cost. They can now use CapChar where it pays to pyrolyse. CapChar fosters insetting across rural supply chains. Our beachhead market ranges from agricultural to local manufacturing. Example customers would have access to waste wood, a heating or a drying requirement, and use for the resulting biochar. Large organisations with net zero targets can decarbonise their supply chain by funding CapChar technology in return for carbon credits. We could help the UK businesses eliminate 1 million tonnes of CO2 annually by 2030. And by 2040, our global ambition is to be a market leader in BCR with 100,000 sites using our technology through local licensing agreements, removing 50 million tonnes of carbon dioxide annually. Despite representing 89% of voluntary carbon removals, the biochar carbon removal market needs institutional support. The GGR Accelerator would support CapChar on its journey to commercial success by helping with funding and regulation, as well as some of the things on the slide. Policy support for biochar gives market confidence, making it an attractive proposition for risk-averse investors. Advocating for an end-of-waste status for biochar eliminates regulatory uncertainty. Biochar carbon removal is the quickest path to GGR today with multiple secondary benefits. Thank you for listening.
Wonderful. Thank you so much, Adam. I'm going to hand over to the judges for 5 minutes of Q&A.
Hi, Adam. So you're selling to quite a diverse set of customers across kind of different markets, very fragmented. So I'm interested to know how you're going to sell to them and scale up your sales to all these kind of different pockets of local markets and customers.
Thank you for the question. We have seen a massive opportunity in what I would call the B2B2B market. So where an organisation has already set a net zero target, maybe 2030, 2040, 2050, they have a need for local carbon removal credits. And the problem is that they just can't get hold of those. So they are very, very well connected. So local authority will know country estates, they'll know farms, they'll know local manufacturing businesses. So we believe there's a real opportunity to connect with one sales point, if you like, that can then open us up and utilize their network to find lots of people who can then use the technology and find this new business model where they might be able to fund the capex of our technology in lieu of the actual on-site business using the heat and the biochar.
Thanks.
Hi, Adam. Thanks for the presentation. You've laid out some quite impressive scaling over time. At the moment, you're quite a small team. Can you just say something about what you expect the team to look like or what gaps there are in it at the moment to building for that future growth?
Yeah, absolutely. So we, thank you for the question. We know that we need to build an engineering team. So we will most likely have an in-house engineering team, which will involve process, mechanical, electrical engineers, as well as probably do some outsourced engineering. We have two bits of technology, if you like. One is the heat batteries. So unlike the previous startup, we don't use electricity. We obviously use exhaust gas. So there's still some work to do from that perspective. So we'll probably have people in-house to do that. And we will probably outsource some of the pyrolysis technology, which is much better well known, and use engineering prowess with other companies. So we expect that to be part of the business. A materials scientist would be another, business development, and as I say, outsource manufacturing once we get to the point of super scale.
Thanks very much. My question is about the pilot plants that you have completed or the customers you've worked with. I'd be interested to understand how has your approach or the technology changed as a result of the pilot implementations that you've done?
That's a great question. So we implemented, I guess you call it V1 technology on both of those sites in 2024. So what we've gained is enormous operational experience, understanding where the technology limits are and how we can improve those. So it's been a very important process. We've sort of JV'd with one company who we've been working with down in Cornwall and another site up in North Wales. For us, it's been about making sure that we can reduce the risk, so understanding operational safety, understanding gas management. Batch pyrolysis technologies does not scale linearly, and therefore the idea of doing a batch at 20 cubic meters rather than 1 cubic meter and then modularizing is a scary amount of gas that will come off at the same time. So from our perspective, it's been about understanding where the problems lie and therefore how can we solve those with in a quick succession, iterate quickly to be able to commercialize the product.
Thanks, Adam. I've got a question more around the carbon credits side of things. Do you see any challenges around the adoption or sales of carbon credits using your kind of own in-house registry, if I've understood that correctly, especially around what challenges might be associated with the kind of inherent conflict of interest there?
Yeah, definitely. Well, we're trying not to be the judge, jury, and executioner. So we don't do everything. We do outsource to third party for the verification against our code. The reason that we've gone down this path is that there is no current way for somebody who wants to use batch technology in the developed world against all of the codes that are out there. So that's why we developed it. We are totally open to someone taking our code, maybe an academic opportunity, or say the Woodland Carbon Code or the Peatland Carbon Code, to take it on board and take it forward. So we don't see there being as a conflict of interest. In fact, we see it important to our survival until there are other opportunities where you would be able to certify this. I think one of the things I mentioned about potential GGR Accelerator support that we would need is to help develop that code and work towards certification with ICRA, which would be then open us up to what blue chips are looking for when they purchase carbon removal credits for their GGR accountancy, for it, in their eyes, to be legitimate.
Thanks very much.
Thank you very much, Adam. Just before we say goodbye to you, if any of our audience members have questions or want to get in touch, is that okay with you?
Absolutely fine. Please do. Via email, adam@capchar.com, or LinkedIn.
Amazing. Thank you so much, Adam. Okay, our penultimate pitching team, back in person now. Please help me to welcome Wood Tech.
Hello, everybody. My name's Stuart Jones. I'm the co-founder of Wood Tech Engineering. This is my brother Darren, also a co-founder.
I'd like to introduce you to our technology, the C1000 biochar plant. This is over 7 years in development. For every 100 kilograms of biochar we produce, we actually produce 1 megawatt of clean energy. This is by far the most efficient biochar system available on the market. We're not aware of anything that can provide more energy from this amount of biochar. With more modern ORC technology, we can now achieve up to 180 kilowatt of electricity from this machine. That's serious electricity. And here's the thing, biochar works. On our own research and development farm, biochar has become the backbone of regenerative agriculture. They say a picture says 1,000 words. Well, that field is 1,000 ton of carbon. Every 2 years, we sequester 1,000 ton of carbon. In just 4 years, we've increased the total exchange capacity by 64%, and every year we've increased the soil carbon by 0.45%. To put that into perspective, in good regenerative agriculture, 0.1% a year increase is seen as a good success. Now, here's the thing. The biochar is easy. Putting the biochar on land is even easier.
Yeah, so I think we're all aware that the biggest challenge we face is scaling carbon capture to a level where it makes a real global impact. So today we wanted to share a vision of ours where we can show you a roadmap to scale to 1 million tons of CO2 annually. So just to go through a few numbers, if you took 500 of our C1000 biochar plants, that is what it would take to capture the 1 million tons annually. Now, to produce these, all we would need is 3 factories producing 12 plants a year. Doesn't sound crazy, right? So if you think about just 3 factories globally building a global climate solution. But this is where it gets really interesting. So as Darren said previously, the high efficiency of our technology allows us to produce clean, renewable energy. Now, if we take this energy and we power AI, the most extraordinary technical revolution of our generation, what this does, this gives us the opportunity to make a business model extremely strong to scale globally. So sorry, I've lost my train of thought a little bit. But, so, and I just want to explain why AI, because currently, if we export to the grid, we get about 8 pence per kilowatt of energy. Thank you, government. Helps a lot. AI can deliver probably between 5 and 6 times that already. Even tomorrow, I could buy a GPU rack, I could install it, and I could get this income. So what this does, it gives us a model, a strong business model, where AI drives the growth, biochar delivers a carbon solution, and together they form a self-reinforcing loop. Now, I want to just give you a couple of numbers. So if at the end of a 10-year period, at the end of 10 years when we would be delivering 1 million tons of CO2 annually, along with that, we would be producing 400,000 tons of biochar and 72 gigawatts of AI, 720 gigawatts, sorry, of AI computation. And if that isn't a scale solution, I don't know what is.
So here's the thing. Our technology works. We've proven it. We're capturing carbon, we're producing biochar, we're producing clean energy. But proving it is not enough. We need the world to scale the biochar. And we think we are uniquely positioned in a way that combining our technology with carbon-negative AI, we can actually build a business model that allows us to scale biochar to the size it needs to be. Because we need to get biochar into the ground, into our water. You know, we've been using it actively for 6-7 years. Our research and development farm is a mecca for field trials, if some of you have probably been there. And this is what we need to get to. And the reason we're here today is we're ready to build that future, and we're looking for partners to build that with us. Thank you.
Well done. Well done. Yeah, that's perfect. Thank you. Well done.
I survived just.
Did an excellent job. Thank you so much. Great. Over to the judges for Q&A. Thank you.
Yeah, tell me a bit more about the AI plans, because are you basically building data centers then powered by your...
You could call it mini data centers, yeah.
Yeah, mini data centers.
Yeah, so basically, the beauty of this is it can be extremely small. So you could take a single machine, you take a small collection of AI GPUs, and then this is actually on the decentralized market. I'm not sure if you're fully aware of what that is. And so basically, I could do a deal with any company that wants AI computation, and they would just get pointed towards our GPUs. And then that could be scaled exponentially, you know. And one of the key points is the whole, say like a turnkey solution could be situated anywhere in the world. And fundamentally, you don't need a grid connection because we're generating the power. And potentially with some battery or some other technology, one that may be seen here today is quite interesting, you could island the solution as well. So you don't need zero grid connection, you just need the data connection.
Okay, and at scale, what kind of scale can you actually deploy with one plant that you're deploying? How much energy can you supply?
So the single C1000 produces 1 megawatt of energy. And with that, it's purely down to which heat engine you put with it. Best efficiencies currently give us about 20%, you know, in a perfect world. But I'm aware of 2 technologies that are coming on board in the next 2 years, which could push that 25-30%, which would be something else.
And there is a balance there too, because when you're working with biochar, it's more than just the carbon credit, just the energy. It's what that biochar does, it's what the feedstock is saving. So you might have less AI computation on one project, but you're using a far more waste feedstock. So it gives you that balancing act that I really like when putting projects together.
Thanks very much. Am I right in saying, is the business model here like machine and kind of set up sales, or is it like a licensing model, or kind of what is the, you know, where's the money coming from in this scenario?
Yeah, well, this is the problem. It's always the money. Basically, where we're at now, we've actually been on this journey, like we said, for like 7 years. It's a very difficult journey. We've got here no loans, no investment, nothing, just old-fashioned hard work, reinvesting the money that we actually make from another plant that we manufacture. So we have just focused up until this point purely on like perfecting the technology, producing high-quality biochar. And that now we're at the point where we're extremely confident in the consistency and the quality of the biochar that we can put out, at the point where we don't even we need very little user input on site to actually, for the machine. So this makes us extremely confident to actually now to think about scaling. We just need partners to do it.
Thank you for the presentation. Could you say something about what you need as a business, sort of short-term and medium-term, to get to market, and what your sort of plans are around that?
Yeah, so where we are, we've already got machines rolled out with customers. We've got our own machine. You know, the electric generator on our own machine is used to actually manufacture other machines. So we're in a unique situation. We can do what's available to be done with what's available, financial side. So we can either just improve our existing ORC technology to a more modern ORC, which will give us more efficiency, and scale up and say £300,000 worth of AI computation, or we can put a whole second machine in, have the two machines doing a larger ORC and go quite large. So we're able to scale based on the opportunities that are there at this day. And then we've got, if tomorrow the government gave us 30 pence a kilowatt to export electric, I would have my order books full for 2 years. So we've got the opportunity of projects ready to go.
Yeah, and just to touch on that, I think on the AI side, I would say we're at a point where proof of concept is the next stage. I don't doubt for 1 second it will work. I've been doing a lot of work on this over the last 12 months. Spoke to engineers, spoke about infrastructure, everything that's needed. I know it can be delivered. We just need to finance a proof of concept. And I think from once that's proven, it can grow and can grow rapidly.
Which on-chain decentralized marketplace for GPUs have you spoken with? What's their feedback? And then why not similar for energy supply to Bitcoin mining, for example, where I've seen micro hydro work well and others?
Yeah, well, that's actually where my original conversations came from, was Bitcoin mining, because I needed to create more value in the heat that we have, and I recognized that we had more heat than most of our competitors with the same technology. So when I reached out to the company, I think the company was called Crypto Hunter, and he was being amazing, because he invited me up there. He said, look, there's all these, he had GPUs running for the Bitcoin, or ASICs computers, sorry, for the Bitcoin. But at the time he said, look, this has worked, it pays back, but it's hard to finance against because the crypto market's unstable. He said, AI is where we're turning our focus to, because this is much easier to get a contract, it's more stable, it's easier to finance.
Okay, and sorry, have you started speaking with one of the on-chain marketplaces for GPUs or not?
Not in great depth. I tend to go back to him all the time, and I just get constant updates, where's the price at, this type of thing. And then obviously, because we'd be carbon negative generation, you'd like to think we could demand a good value for the computation.
That is all we've got time for. Thank you so much. Thank you, well done, thank you. Okay, we've got one more pitch to go. I'd like you all to stand up, please. Whether you like it or not, we're doing the standing up thing again. Yeah, have a little stretch, maybe shake a leg out, and then shake your other one out. Shake this one, shake this one. Shake, shake, shake. I'd like you to turn to somebody who is sat behind you or in front of you and say, is everything going okay? Are you all right? I'm okay. Are you okay? Are you okay? Is everything okay? You okay? You okay? Everyone okay? Are you doing all right? Are you okay, Genevieve? You're all right. You're all right. Are you okay? Right, yeah. Okay, good. Okay, great. I'm so glad everyone's doing okay. Big sigh and sit. Thank you. Wonderful. Okay, our final pitch of the day. This is very exciting. Please help me to welcome for the final pitch, Origin. Woo!
Hey, everybody. This chap here is a gentleman called John D. Rockefeller. His journey is an incredible entrepreneurial story, from the first oil well in Pennsylvania to the company he built, Standard Oil. Now, within decades, that business was worth billions of dollars in a $1 trillion industry, and that industry was oil and gas. Now, today, carbon dioxide removal represents the same size opportunity, but perhaps more fundamentally, as we've heard numerous times today, it's absolutely critical to achieving our climate ambitions. And that's why we exist at Origin. So we are focused on at-scale, low-cost, limestone-based direct air capture. We have a very simple process, and it involves 3 key steps. Firstly, we take limestone, it's about 10% of the world's surface mineral. We heat it up to 1,000 degrees centigrade in a proprietary kiln to produce highly reactive lime, or calcium oxide for the chemists, and a pure stream of carbon dioxide that can be safely sequestered. We work with partners like Shell, Mitsubishi, Sumitomo, ConocoPhillips to do that side of things. That reactive lime is then mixed with water in a really carefully controlled reaction to produce calcium hydroxide granules. They're really hungry for carbon dioxide. And then in step 3, those granules go into our proprietary air contactor, where those granules remove carbon dioxide from the air. As those granules remove that carbon dioxide from the air, they reform the limestone. It's looped back into the beginning of the process. So it's really simple, it's extremely elegant, it's incredibly scalable, and it's low cost. So we've actually built this. This is a picture of our demonstration facility in North Dakota in the US. We developed this alongside an engineering partner called EERC, as well as Hatch, who are one of the biggest EPCs in the world. This picture here is a really big piece of kit. It's 8 stories high. It's cost us about $6.5 million to build. This is the lime that we've produced from that. This is incredibly reactive. The data from this demo has been way better than expected. You see granules just on the top, and it's those granules that actually do the carbon removal. And then the contactor is the white box, and it genuinely is a white box, although there's some pretty smart engineering that goes on in there. Secondly, carbon dioxide removal, in particular direct air capture, is all about energy, and Origin is energy advantaged. Let me just talk you through that. It is not just the cost of energy that matters, but it's the availability of energy that matters. And in a world where data centers are hoovering up clean electrons, we fire our process on thermal energy, natural gas, in a closed-loop zero-emission process that allows us to scale without those same challenges. And furthermore, the cost of renewable electricity is not as low as everyone thinks it would be. Our energy cost is about $12 to $15 per megawatt hour. If you look at the latest PPAs signed for 24/7 firm renewable electricity in the US, it's upwards of $100 to $150 per megawatt hour. So we're advantaged on that side of things. And then we've started from scale and worked backwards. All of our process works in industry. We've leveraged technology from cement, from lime, from the minerals industries that allows us to scale more quickly than the vast majority of other technologies in this space. And so what does that mean? We've been selected by Shell and Mitsubishi to deploy this technology at meaningful scale. We're developing a 200,000 ton per annum facility in Louisiana at this disused oil refinery. It's a big project with serious partners. Shell have even invested directly in Origin, and we've pre-sold removal credits to both Shell and Mitsubishi. We've got an amazing team. Deliverability matters here. Our team is filled with people who have industrial expertise, and deploying technology at industrial scale really matters here. And those partners bolster those capabilities. And where are we today? Well, we closed a Series A earlier this year, that allowed us to prove that technology and develop that commercial traction. We're currently raising some capital to accelerate the commercialization of the technology and mature that project to shovel ready. And then we'll be raising a Series B next year or late 26, early 2027 to build that project. So we got some incredible traction. We've proven our technology. And for us, it's really about maturing that, keeping this moving to the point where we're deploying technology at meaningful scale. Thank you very much.
Well done, thank you. Okay, over to the judges for 5 minutes of Q&A.
We're stunned. Could you say something about what the next raise is going to be used for?
The 5 million? Yeah. So with us, the demo's online. We've kind of got 3 uses of capital. One is further technical de-risking. We've done most of the de-risking, but things like materials handling really matter. So we'll be running some more testing on that side of things. But the majority of capital really is to mature that project. So for the engineers in this room, we are currently doing what is termed a pre-feed study, preliminary front-end engineering design. We're about 80% complete on that. But the feed study, where we're doing much more detailed engineering, is pretty expensive. It's kind of £2.5 million or so. So a lot of the capital is really used to fund that. And then we've got, obviously, people and overheads just to kind of keep the business lights on.
Sorry, and the scale of that next plant?
The next facility, so the one I was showing with Shell and Mitsubishi, that's 200,000 tons of carbon removal. That's a $500 million project. Shell and Mitsubishi likely to contribute their pro rata share, about half of that. And for us, it's going to be on us to find the balance. I think one of the key points I would make, the pricing off that plant is really critical. We'd be selling removal credits from a direct air capture facility in the mid $400 per ton price point. That's incredibly attractive. That's attractive for the likes of Microsoft, Airtel, and with Microsoft being the kind of leader in this space, getting them on board as an off-taker is pretty fundamental.
I'd love to know more about kind of your longer term scaling and maybe the cost curve around those credits, if you're able to share.
Yeah, absolutely. So from a scaling perspective, that same site I showed, and if I can flick back a little bit, we have the opportunity to scale 10 times at that site to a 2 million ton per annum facility from that kind of 200,000 ton. Our cost curve is very well understood. We're using pre-existing industrial components packaged together in a novel way. We can get to a $100 to $200 per ton price point, where a lot of the optimization on that cost curve comes from sourcing of materials, natural gas pricing, et cetera, et cetera. So from where we would be today on that demo, which is in the thousands, and frankly, it's not designed to be economic, to that scale-up project where you're kind of looking at sales prices of 400 to megatons in the $100 to $200 per ton price point. That's where we anticipate being. Difficult, and we can have this debate endlessly, but I don't really think $100 per ton is the right number. It's a number that was thrown out there by David Keith however many years or so ago at Carbon Engineering, and it's a number that has kind of stuck in people's minds. So I think it's a little bit of a red herring at times.
Yeah, absolutely. Nice round number, but just another question as well on your limestone feedstock and your natural gas are both kind of finite natural resources to it. At an extent, are you doing any work to kind of broaden that scope to a slightly more kind of circular economy?
Yeah, so I mean, natural gas is price and availability advantaged at this point in time. And frankly, there are so many opportunities globally for us to kind of leverage methane mitigation type strategies. So I'll give an example. We're speaking with the Ministry of Energy in Iraq, who have got a massive methane flaring or venting issue. If we can take that methane, burn that in our kiln, and use the chemical energy to essentially remove CO2 from the atmosphere, you avoid the methane global warming potential, and you get the benefit of carbon removal. That's kind of what our focus is on the here and now. From a tech roadmap perspective, plenty of opportunities to electrify. We probably look at something that looks like hybrid electrification before we go whole hog electrification, because as I kind of framed up, that rush for clean electrons is a difficult game for us to win out in, because I don't think we have the pricing power or indeed the kind of margins to play with in the same way as a Google does.
Very briefly. For
We've got 14 seconds.
What are the key things that they're looking for other than price that you need to prove out with that project?
I think from a buyer's perspective, deliverability is probably the word I would use at this point in time. There have been an abundance of carbon removal projects that have promised and failed to deliver. And so for us, working with partners like Shell and Mitsubishi, Hatch, Wood, etc., who know how to deliver projects is a big positive for us. I think the other aspect is, as I said, packaging together all of your supply chain to make sure things happen really matters. And I would tend to say that as we're engaging with the Microsofts of the world and the other buyers who are out there, they care about well understood costs which come from these pre-feed studies, these feed studies. So counter to a couple of years or so ago where there was a little bit more hope and we're prepared to take the risk, I think the hurdles for real engagement have kind of moved.
Thank you.
Wonderful. That's all we have time for. Thank you so much. Okay, that's it. Those are all the pitches. I'm now going to ask the 4 judges to leave us. So join me in saying goodbye to our judges for now. They'll be back. They are going to narrow down those 9 pitches to their top 5 favorites. And we will hear from them shortly once they've done their deliberating. So if I could just send you out that door over there. And we'll see you very soon. Thank you, judges. Thank you, thank you. And while they are deliberating, we're still going to have some fun here. I am very excited to introduce Jovita Das, a deep tech serial founder and angel investor with over 12 years of experience in creating world-class organizations. An engineer by training, lived in 3 continents and studied in 3 different Ivy Leagues. Jovita brings a deep passion and expertise to climate sector with her current venture, Samudra Oceans, as well as being an advisor to UK Innovation and Science Seed Fund. Thank you so much for joining us. Welcome, Jovita.
Thank you so much. Hello. Yeah, okay. I think I have a really tough job today. I'm not pitching, so immediately anything I say is less interesting and less important. And thank God I'm not pitching, because I do that almost every week of my life. So I'm going to try and bring up my slides. Yeah. So I want to talk a little bit about this room that you've been in, all of us. Take a good few seconds and look at each other, wherever you're sitting, above, below, next to each other, because this is an incredible room. You have listened to amazing, courageous people who are not only doing the impossible task of making a company, they're doing it for CO2 removal in 2025. I think you all know what I'm talking about. We've had incredible judges who have a job that I do not envy. We have the incredible Emily keeping the energy up, the organizers and the team who've given their time to this, and all of you who could have been doing anything, going for a job, watching Netflix, chatting to a friend, working for another ridiculous project you don't believe in. I don't know, but you're literally here. You're curious, you care, but you're here because you really care. And that is a great room to be in, because believe me, there are 1 billion rooms across the world right now that do not look like this, that do not feel like this. So I do want to talk about this room. I always say I'm a poet wrongly born in the body of an engineer, so I will definitely start with this poetry. Letter to someone living 50 years from now. Most likely you think we hated the elephant, the golden toad, the thylacine and all variations of whale harpooned or hacked into extinction. It must seem like we ought to leave you nothing but benzene, mercury, the stomachs of seagulls rippled with jet fuel and plastic. You probably doubt that we were capable of joy, but I assure you, we were. We still had the night sky back then. And like our ancestors, we admired the illuminated doodles of scorpion outlines and upside-down ladies. Absolutely, there was some forests left. absolutely, we still had some lakes. I'm saying it wasn't all lead paint and sulfur dioxide. There were bees back then, and they pollinated a euphoria of flowers, so we might contemplate the great mysteries and finally ask, hey guys, what's transcendence? And then the bees were dead. Sorry, bit depressing. But this is the letter we don't want to write. That's my point. This is the letter we don't want to write. So I want to talk about some of the rooms that couldn't be here, even if they want to. We're standing at a time in history when we have the highest number of armed conflicts in every continent across 3 decades. And you know what that means for the ecosystem to recover, both from an ecology, sociology, and economics perspective for any climate crisis. They could not have been in this room even if they wanted to, but we're here. I also want to talk about another kind of room I'm in a lot. That's my background, AI. I heard a lot of talk in some of the pitches. So I was in AI at a time when cloud credits were not cheap. I'm kind of giving away my age here, but I had to kind of build my own server at home with NVIDIA line cards. So I've seen the whole hype cycle of, why are you doing AI? It was called machine learning mostly back then, to like, everyone's doing AI, why are you different? And I'm in rooms where I've seen hundreds and billions of dollars being spoken about in AI investment like it's nothing, nothing. The biggest investment on this planet in every possible way. Private markets and now public markets as well. And that begs the question, this all-powerful technology that makes other technology, what is it that it is put to use to? What is the maximum use coming out of this billions of pounds and dollars invested? Marketing and sales. 60% of AI investment will be marketing. Faster, more, just more of I don't know what. And I wonder if we could take this big fire hose and point it towards the biggest solutions we want on the planet, i.e. the room that we are sitting in, worth thinking about. And what exactly does this mean? Why am I bringing out AI and global conflicts? Trust me, I will tie it back together to this room. And I want to tell you that AI has created, not directly, but also indirectly, the maximum number of billionaires we've ever seen in the history of the world in the last decade. And 7% of those people are responsible for more than 2/3 of the world's emission. The top 1% cause 20% of the world's emissions. The top 1%. This is a real number. Google it up, verify from World Research Institute, wherever you like. And so we have a disproportionately powerful technology that if we don't use proactively is being used to do what every technology has always been used to do. Make the rich richer, the poor poorer. Except this time, the planet's a stakeholder getting very poor. So is it the consumption? Is it all the private jets and expensive food? Sure, but it's also the investment portfolio. The maximum investment portfolio, if you quantify the carbon emissions, the water footprint, and the biodiversity footprint of the biggest personal portfolios of multi-billionaires in the world, you will find that their emissions can wipe out, will cause heat-related deaths of something, the state of Dallas will be wiped out. That's what it means when we don't proactively invest. This is what we are causing. There's no neutral party. You either invest proactively for the climate or you're investing against it. You're directly responsible for floods, droughts, death, disappearing of ecosystems. There is no such thing as neutral finance anymore in the world. You're either pro or you're actually proactively killing it. Doesn't matter if it's hidden metrics in your portfolio. And so this is very interesting because while all of this is happening, we're talking about wealth. What's happening to poverty? So if you go to sub-Saharan Africa, we're still talking of 60%. So that means when you're walking on the road in a sub-Saharan town or village, if you meet 2 people and you said hi, one of them is most likely struggling with their daily food supplies. 1 out of the 2 people you just said hi to. If you look at Europe or UK, the bottom green line, we're still hovering below 10 to 5%, despite all the things we're saying, because that just basically means if you walk into a pub and if it's not superbly crowded, it's less than 25 people, none of them today have thought about their food supplies for a week because they're fine. That's the difference. And all of this just makes me think that what is actually going on in the world? How is the climate crisis connected to everything else? How does it tie into personal responsibility? How does it tie into national policy and to each one of us in whatever capacity role that we are in? I was in this room actually 3 years ago, so I know a little bit about rooms, by the way. And I've been in a lot of the rooms that I mentioned today, a lot of the rooms who cannot be here even if they want to, and a lot of them, as we just saw, will not be in this room because they cannot. I was here raising my first million for a company that had incorporated my fourth venture. In the past, I had 2 exits and 1 glorious failure. And then this is the one we came out with. I did end up raising twice of what I was hoping to raise. We've gone on to do more and other stuff. So I know a little bit about those rooms. But you know why I got out of the rooms I was in? Some of them very much like the rooms I mentioned in the beginning. Because of incredible people, some of whom are probably sitting here, who actually bothered about bringing people out of that room into this room. One of them is my mom here, scientist and teacher who taught me about climate change like 30 years ago when no one was talking about it because she knew about it. And she made an effort to teach me. And so every single one of us, if we participate, I think these rooms and these letters need not be written. We can have a completely different outcome. Looking at the pitches today and the power of everything people said, I think we're really looking to a place where I don't think we have to write that letter if all of us participate. So in summary, we're really lucky to be in this room, to be in this moment. It comes with responsibility. 2, AI and tech is actually rewriting the entire future, the age of the Anthropocene. Can we turn that fire hose towards the solutions that matter? And climate finance needs to increase by at least 5% to meet the goal that we need to meet by 2030, which is exactly what today's pitches and everything was about. So we're in the right room. So great news, everybody. We're in the perfect room. And I will want to end with my favorite poet, Rumi, who said, in the dream, he doesn't remember the town he's sleeping in his bed in. He believes the reality of the dream town. The world is that kind of sleep. The dust of many crumbled cities settles over us like a forgetful doze, but we are older than those cities. We began as a mineral. We emerged into plant life and into the animal state, and then into being human. And always we have forgotten our former states, except in early spring, when we slightly recall being green again. I hope all of you felt a bit greener today, and thank you very much for being in this room.
Thank you so much. Thank you. Thank you very much for that. It's lovely to have a bit of poetry at the end of the day. Wonderful. I'd like to invite David to come back. David, we're going to have a little chat now. Wonderful. Do you have a microphone? Okay. How are you feeling? Has it gone well?
I think everyone has enjoyed. Have you enjoyed the evening? Yeah? The pitches? Amazing hosts. It's been fun.
Some very exciting startup pitches. So great to see the whole greenhouse gas removals portfolio demonstrated for us today.
Absolutely.
Before we get the judges back in, if they are deliberating away in the background there, let's take a minute to talk a bit about CORE.
CORE, for sure. So as you know, this is like a 3-day event. Some of you, came for, Monday and Tuesday. So thank you for sticking around. Obviously, we wanted, from the innovation side, finish with a big splash. I hope we have delivered. We're leaving the last bit to the judges so we can learn who's joining the Climate Accelerator, the bespoke GGR program. But obviously, the story doesn't end. CORE is wrapping up, but we're going to be still running events, obviously, this program. If some of you, what you saw today sparks something and you want to build your company, we're happy to get in touch, either with CORE or with the folks at Undaunted, with me in particular. So these are the socials, you can find us there. But I wanted to, kind of connecting with what Joyita was saying, being in the right room, getting the support, sort of building this village. I just wanted to have the opportunity to, thank some of the people that have been involved already here. So I wanted, with order maybe of no importance, but everyone together that came to make this happen, obviously. So the core team that has been obviously crucial. So if we can give them, a big round of applause to Michael, Emily, Natasha, who's over there, Maisie, everyone that has been the tech team, our amazing hosts that have been, fun to watch. And all the volunteers that have been around, the people at the Royal Institution. So I just wanted to, all together with the judges as well, thank you with me. A round of applause to all of them. And I think Emily also has a special message to talk about, the future of this community.
Yeah. Also, thank you to you, David. It takes a lot to put an event like this together, so well done. Thank you. Can I get a whoop whoop from any FLNers in the room? Oh my gosh, love it. Thank you. The Future Leaders Network, also known affectionately as the FLN. I came across the FLN a couple of years ago through my work on the Carbon Removal Show podcast, and it is such a friendly, welcoming, inspiring place to connect with other members of the CDR community. I recently became the co-chair of the Future Leaders Committee, and we're at a very kind of exciting time. We're moving into a new chapter. We're rediscovering what the FLN is going to look like in the future. We are planning ahead. So if you would like to join us and connect with, we have over 200 members now, so there's lots of people to connect with from all sides of the CDR and GGR worlds. So if you'd like to sign up, please join us. It would be so wonderful to have you.
Emily.
Fantastic.
Yeah, before we
David.
invite the judges, Emily.
Are we going to talk about the little...
We can talk about it.
I think we should talk about that. But you just say what you were going to say.
Yeah, I just wanted to give a big, huge, thankful, kind of acknowledgement to someone that has been so instrumental. If any one of you has run events at all, ever, that it's a lot of work, a lot of planning, a lot of firing, fights everywhere. So I just want to call Kate, who's going to join here. She's from Undaunted, and she's been my right hand. So I just want her. Thank you, Kate. She doesn't want to talk about it. I'm sure she's very happy how everything has gone. Now you.
Thank you. The judges have reappeared. But before we get them back with us, I just wanted to mention, as we said, the winners, the top 5, are all going to be welcomed onto the Undaunted Accelerator program, which is very exciting. Everyone who pitched today is going to get a little gift in the form of a little tiny bag of biochar. These were gifted by Restored, a UK biochar company in Cornwall, and they document their whole business journey through an award-winning podcast called Grounded, a climate startup journey. Check it out if you want to know anything about their entrepreneurial journey. It's really really great listen, and I believe there are some new episodes coming out soon, so there we go. So yes, everyone who pitched as a little thank you is going to get some biochar to do whatever they like with. Okay, judges, please come and join me up here. Excellent. Round of applause for the judges, please, everyone. Welcome, welcome, welcome. Let's get you some microphones. Here you go. We've got enough. Microphones, please. Thank you, thank you. Okay, so you are going to tell us your top 5 from the 9 pitches that we saw. I would like to ask that we go one at a time. So we're going to get each team that you announce, we'll get them up, we'll give them a round of applause, we'll give them their little baggies of biochar, and then we can move on, and the next person can announce the next team. Does that sound good? Fantastic. Okay, I'm very excited. Go for it. You go, you go.
I think I'm first, by virtue of the fact I walked to the room first. So I would say that this is not an easy task, and I want to say thank you to everyone who took the time, effort, and energy to pitch, because it's not an easy thing to do, and it wasn't, therefore, made it not easy for us either. So thank you for that. So these are in no particular order. First up, because we think that the company is at a stage that is going to be really benefit from the program, and because we think vice versa, also the program will benefit from that company being on it, and also that there's some really good co-benefits with the technology, and partly because I love a good story, we've picked Remedium Energy. So well done, Remedium.
Woo! Where's Remedium? Are you at the top there? Come down, come down. Okay, well, we can give them their little baggie of biochar when they get down. It's a little bit of a walk. But Genevieve, would you like to announce the next one, please?
Yeah, the next project that we've selected due to the incredibly charismatic nature of the project, the social impact they may have, and just the fact that I do love a little bit of ocean storage, it is BlueSync. Is that BlueSync?
Wonderful. I don't know if BlueSync is still with us. Yes, they are. Ellie, congratulations. Your biochar will find its way to you, I promise.
That's fine. Thank you so much.
Congratulations, Ellie. Well done. Excellent. Michael, would you like to say the next one?
We've also selected a company based on the embeddedness in existing practices by farmers, supply chain pull from buyers, and this idea of infrastructure play and the fact that it's working on first of a kind in a greenhouse gas that is not CO2 and therefore interesting from that perspective as well, Crop Intellect.
Are you up there as well, Crop Intellect? Come on down. Okay, while you're up there, we're going to get you over here for your biochar.
Right.
Come and get your biochar, please. Well done. That was a great pitch. Thanks for that. Michael?
So the fourth company was selected probably not because they would benefit the most from the biochar. I think they may have come across some biochar before. They've developed a very promising technology. They've already deployed some units. And I think they've identified, and we thought they've identified a very interesting market in terms of the hyperlocal AI compute. Have a lot of work to do still there and can really benefit from the support of the program, and that's Woodtech Engineering.
Oh, they're up there. Excellent. Congratulations, Woodtech. Very exciting. A little baggy biochar. A little baggy biochar. Yeah.
There's a certain irony of being handed biochar in this moment.
I know. I'm just going to ask that you stand slightly over that way while we announce the final of the top 5. And then I'm going to ask that we get all of the pitching teams. So if you're up there, make your way down. Because we're going to get some pictures at the end. So let's hear. David, do you want to go back to? Oh, Genevieve, sure. Yeah, please.
Yeah, so finally, and last but not least, the final project was selected due to, I guess, as Gabrielle said, it's about the size of the gap, it's about scalability, and we think that Origin has a really strong potential to really be breaching and getting to that scalability that we need for the CDR market.
So congratulations, Origin. I don't know where Origin. I think everyone went back up there. This is yours. Congratulations. Fantastic. And also congratulations to the other 4 teams who pitched. All the pitches today were excellent. Thank you so much for joining us. I'm going to ask the judges to sit back down. Thank you so much for your deliberations. Teams, can you stick around? We're going to have pictures just in a moment. But before we close, where's my little clicker? Before we close, do you have any slides? Okay, great. Before we close, I just want to hand over to Steve Smith, who's going to close the day for us. Thank you so much.
Thank you, Emily, and thank you so much for hosting so well today. It's been a lot of fun. I'm going to be super quick. For those of you who don't know me, Steve Smith, I'm the Arnell Associate Professor of Greenhouse Gas Removal at the University of Oxford, which is a bit of a mouthful. But the main reason I'm here today is because I'm Executive Director of the Core Project, which is part of this GGR-D program. It's been a three-day GGR Fest. How many of you have been here for the whole 3 days? Yeah, we've got a few hands up, well done. But it's also really nice to see that a lot of you have just come in for today or come in for 2 days. Because like the research program as a whole, this has been a really unusual and unusually rewarding kind of conference, I think. When you think about UK research funding, you probably think about boffins in labs. There's been a certain amount of that in the GGR-D program. But what I think has been really special and enjoyable about it is it's brought together a huge number of researchers across a huge number of disciplines, trialing some methods, so really getting into the guts of the science, but also asking questions about public perceptions, about finance, about fits with broader energy and agricultural and social systems. And also, UK research councils have, of course, been funding, through Innovate UK, deliberate support for people with early stage ideas that are becoming commercial or could become commercial. So the reason why we've had day one, which was really us science geeks getting together and chatting about our work within the program. Day two, which was reaching out to inform and impact a wider audience of stakeholders and people with an interest in this space. And day three has been very much on innovation, on startup ideas. So we've already thanked a lot of people, but I want to thank all of you as well for being involved over the 3 days. I hope we can keep the conversation and stay in touch. I think it falls to me to say you're all welcome to go forth and have drinks and mingle. We've got a bit more time out in the foyer, so do please get in touch with someone you haven't spoken to before. Speak to the startups and the judges as well, and we look forward to seeing you again soon. So thank you.
Thank you, everyone. Just a reminder for the teams to come and get your picture taken with the judges and David. Thank you so much.